This is how to perform roof inspections. This is the last in the 12-part series. My name is Matt Broder, for any of those attending who don't already know. I am a certified master inspector. I'm a licensed home inspector, and I'm a roof consultant. So roofs are kind of my specialty. I've been a roof consultant for somewhere around 15 years. I've done, I don't know, close to pushing 10,000 inspections in 16 different states. So at the end, you'll see my contact info, and please don't, if there's a question we don't get to answer today, feel free to reach out to me by phone or by email. I will put my cell phone number up because I am fine with that. So if you have any questions, text me, shoot me a picture, do whatever. InterNACHI is a great platform for unifying inspectors together, and we all need help. We're not experts on everything. I happen to be a roof expert, but there's plenty of people that I would reach out to for expertise in areas that are not necessarily my number one strong suit. A lot of us come with some kind of a background, and then we kind of expand into home inspections as a broader subset. So anyway, this is how to perform roof inspections. And the goal of this course is to teach inspectors how to inspect the roof covering system of a home. So we will real quick go over the standards of practice. There we go. So according to the InterNACHI home inspection standards of practice, the inspector will inspect from the ground level or the eaves, the roof covering materials, the gutters and the downspouts, the vents, flashing, skylights, chimney, and other roof penetrations, and the general structure of the roof from the readily accessible panels, doors, or stairs. So as you can see, we'll probably get to it in a second, where you're not required to necessarily get up on the roof. I personally always do, just because I'm a roof expert, and we'll talk a little bit about what materials are safe to walk on, which ones are not safe to walk on, and even among safe to walk on materials, maybe instances that aren't so safe and stuff like that. But I will just say the standards of practice, like I've gone over a lot of times, I know Ben is big on it. It's sort of a minimum standard. So you don't fulfill the requirements unless you meet the standards of practice. So it's a minimum to get you in the door to say, I am compliant with standards of practice. Now, every state is a little bit different, but I haven't seen a lot of states that require you to not get on a roof. There are plenty of states, including my own of North Carolina, that our standard or state standards of practice don't require you to get on a roof. You are required to describe the roof covering material and some other items. But again, it's important to note it's a minimum baseline. So as things get further and further with drones and all these other things, you're going to want to have some expertise in the area of inspecting the roof and identifying certain things that it's just going to be too hard to miss at a certain point. So I'll continue without grandstanding too much. The inspector shall describe the type of roof covering materials, and the inspector shall report, as in need of correction, observed indications of active roof leaks. So you're not necessarily required by this standard of practice to observe indications of inactive roof leaks, but I will get to that later, where I do think it is an important component to investigate a little bit further when you see something that's been repaired or maybe even an imminent roof leak. So the inspector is not required to walk on any roof surface, predict the service life expectancy, inspect underground downspout diverter drainage pipes, remove snow, ice, debris, or other conditions that prohibit the observation of the roof surfaces, move insulation, inspect antenna, satellite dishes, lightning arresters, de-icing equipment, or similar attachments, walk on any roof areas that appear, in the opinion of the inspector, to be unsafe, which you're not necessarily required to walk on the roof surface anyway. So if it's unsafe, that's sort of a double do not do that. You're not required to walk on any roof areas if it might, in the opinion of the inspector, cause damage, perform a water test, warrant or certify a roof, and confirm proper fastening or installation of any roof covering material. Now, all that said, just make sure that if you're disclaiming anything, if you're not walking on a roof surface, if you are not looking at something that's very visually obvious, then make sure that it's in the verbiage in your report that you're not doing it for a particular reason. That way, it doesn't look like something that was missed. It's just something that you're not required to do, and for some safety concern or for some reason that you can kind of determine on your own, just trying to use your best judgment, because for obvious reasons, you're not required to walk on a roof surface, even though I would encourage you to. You're also not required to predict the service life expectancy, which I would say never ever do. So these things that you're not required to do, some of them are you're not required to do, but it would be nice if you did. Some of these are like, don't ever do this, right? If there's debris or something that's prohibiting the observation of the roof surface, maybe it's something that it's a pile of tree debris, and for some reason it just so happens to be situated in such a way where it's not causing a leak. You move it to see something, and all of a sudden the roof is leaking, and it's your fault because you changed the condition that you saw. So leave it as a visual only inspection, especially as far as the roof is concerned, but try to use your best judgment when it comes to these things. So next one is we've got a video. So it says roof inspections are dangerous. I don't know exactly the content of this video, but I can tell you firsthand, I don't fall off roofs, but I've seen more than enough situations. I can tell you some pretty bad horror stories that I was second party to. I've seen people fall off of roofs and things go really badly. So again, you're not required to walk on a roof surface. Even though I'm sitting here encouraging you to, what I'm more encouraging you to do is do what you're doing now. Go to education, learn about roofs, learn about roof safety, educate yourself as much as humanly possible. If you're an InterNACHI member, all of this education is free. So take as much education as you can on roofs, roof safety, how to inspect a roof, do all these things, and then develop a comfortability with accessing maybe the one-story roofs that are not very steep. And you continue to grow and master your craft to the point that, for me, there isn't an inaccessible roof for the most part. Obviously, there's outliers when I say that. There's old brittle slate tiles and things like that that are kind of obvious no-nos to walk on. But in terms of your typical asphalt composition shingle, there's not a whole lot of roofs that I find to be uninspectable. So that's based on 15 years and 10,000 roofs of experience, but it's something you grow into. You don't have to just jump on every roof right now, but I'm encouraging you to not look at the standards of practice as a limit, but look at it as something as, I can disclaim it if I don't feel safe, but I'm going to try to get as much information as possible. And that's just my encouragement to all of you guys is do whatever you can to get as much information, because my perspective as a building envelope consultant, I look at the building envelope as the primary water shedding component, right? The roof is the umbrella of the home, and water is the biggest enemy of the home. So there's a lot of building science that goes into how the exterior can allow moisture in and things like that, but the roof is pretty straightforward. We want to be that line of defense for our clients where we can identify areas that seem like they either might be leaking now, might leak in the future, or may have leaked in the past. And we want to collect the information that they're not going to be collecting because they're not as educated as we are and they're not as connected as we are, because we do have each other always. And like I say, I'm not saying that for lip service. If you guys need to text me or call me because you're seeing something that you're not familiar with, I guarantee you I've either seen it or I know a guy who's seen it. So let's stay connected too and educate each other and help each other to grow in this process. We're not competing with each other. There's plenty of business out there for everybody. So let's teach each other, let's learn from each other, and let's do a good job. So safety standards and walking the roof. An inspection of the roof system is both one of the most crucial areas of the home inspection, like I just talked about, and also one of the biggest concerns on the prospective home buyer's mind. Spending a large portion of the inspection time dealing with the roof and following some basic rules will pay dividends to the inspector, both in terms of customer satisfaction, what I can definitely attest to, and also in reduced liability. Safety first, though, like everything else. I hope that you're taking this away from this 12 weeks. Safety is always first, always. No questions about it. You got to go home. Okay, you got to go home at the end of the day to your family, or even just to your apartment and your PlayStation or whatever it is you're going home to. Please stay safe. Before approaching a roof inspection, it's very important to keep safety at the forefront. Too many home inspectors and other tradesmen have been seriously injured by being lax with ladder and roof safety. And that is probably one of the primary parts of safety, is that transition from ladder to roof and roof back to ladder. Some roofs just should not be walked on. One of the first safety issues to consider is that some roof systems simply should not be walked on. In particular, most types of solid tile roofs and all wooden shingle and shake roofs can be accidentally damaged by the inspector. So that's more of a liability than a safety thing, but also in safety, if you break one, that can turn into a nice little surfboard to take you off the roof. In addition, all types of roofs should not be walked on if conditions are wet or icy, or if the roof is mossy or covered in algae, or if it's just too steep. Even when considering walking on a dry roof or a roof of a low slope that's just one floor up, it's important to keep safety in mind. When all other conditions appear to be favorable and safe, it's still possible to put your right foot through the asphalt shingle roof covering of a house due to rotten roof sheathing, which I can tell you has happened to me. 3 stories up, no less. Remember that most of the time, a roof covering can be inspected from a ladder at the eaves, from the ground with binoculars, or from overlooking windows. When planning to walk the roof covering, remember to wear soft-soled sneakers or similar footwear, as they offer a far superior grip compared to work boots, unless those boots are specially designed for walking roofs. I don't think we have a slide in here for it, but the boots that are most preferable for walking roofs are called Cougar Paws, and they have replaceable pads that are made of a soft rubber material. And I would say that is a day one purchase. If you're wanting to walk on asphalt composition shingles, you should be purchasing a pair of Cougar Paws. It's about $220 or so, and then maybe $20 to $25 per set of pads that you shouldn't go through in less than 30 to 40 roofs. So it's a very conscientious investment to keep you safe. It's a requirement for the engineers and inspectors that I train to do this type of work. Walking on a clay tile roof, as you can see, the gentleman in this video is walking on what's known as the headlap, where there's technically, in some instances, 3 layers of material. But the main part of this to take away is do not walk in the field area of that roof. So you can see his left foot is just a few inches up from the bottom. That's where there's a lot of support underneath, and his right foot is about to fall down right on the exact same spot on the next tile down. So what he's avoiding is walking in that center area of that shingle, because it's somewhat unsupported, and especially in the instance of a rigid tile like a slate or a concrete, certainly a clay tile. A clay tile is something that I would say don't ever walk on. But in this instance, he's walking on concrete tiles. And I know it says clay tile, but those are a type of concrete tile that you're looking at in this video. They're very thick, they're very sturdy, but he's still not going to step in the field area in that middle area of the shingle, which I think you can see. I'll just kind of put a laser pointer here. So this area of the shingle is a no-go. This first 3 inches is the headlap where this material is underlying. On a shingled roof, this material might be long enough to be up here. I don't know if these tiles are, but nonetheless, this is called the headlap. It's well supported. It's a safe area for your foot. If you step up here, you will likely have a horizontal crack all the way through that tile, and then the bottom half of that tile could potentially pop up underneath your foot. And again, speaking from experience, not on a tile roof, but on shingled roofs in the past, it's not fun to have something come off underneath your foot while you're trying to walk a roof. So let's talk about types of ladders and ladder safety. So a ladder is an appliance designed for climbing, which consists of 2 side rails joined at uniform intervals by cross pieces, also called rungs or steps, on which a person may step to ascend or descend. Ladder types. Home inspectors typically use several types of ladders to access different areas of a property safely. According to the American Ladder Institute, there are 9 different types of ladders, but we'll just talk about the most common ones. So step ladders, which you're looking at a combination type ladder or a multi-position ladder off there on the right, but it's kind of acting as a step ladder right now. Step ladders are the workhorses of home inspections. Most inspectors carry a 6-foot step ladder for interior work and attic access. When you have the attic access, it's just a pop-up panel without a stairway. And an 8-foot step ladder for exterior work like examining soffits, fascia, and lower roof sections. Step ladders are self-supporting with an A-frame design, making them stable on flat surfaces. And we'll emphasize making them stable on flat surfaces. The nice thing about these multi-position ladders, not that I want to skip ahead, but a lot of them do have, this one shown does not have it, but some of them do have self-leveling on them where there's kind of a ratchet type level, and you can get them level on somewhat unlevel surfaces, but I wouldn't recommend it if it's drastically unlevel, and that kind of gives them an advantage over your normal step ladder. An extension ladder is for reaching higher areas like second-story roofs, chimneys, tall exterior walls. Inspectors use extension ladders for those reasons. The common sizes range from 16 to 28 feet. I would say a 24-foot extension ladder is a very reasonable ladder to carry. If you have the ability to do that on your vehicle. Those can also come with self-leveling feet, and a 24 footer is, reasonable in terms of its size and its handleability. If you go up to a 28 or a 32 foot, they can get a little bit unwieldy, and that can be true also if you're talking about an aluminum extension ladder versus a fiberglass extension ladder. The fiberglass counterparts are much, much heavier. And then on the aluminum side of things, especially with Werner, that's kind of the main dog in that space. The Werner ladders have different color tips, and you can tell the weight rating for the ladder is going to kind of correlate to how heavy duty and unwieldy the ladder is. So if you have a 225 ladder that I think might have red tips may actually be 200 pounds, but the blue tips are rated for 250, and then they go higher than that. So if you get a blue tip ladder versus a green tip or a red tip ladder, the green or red tips are going to be much lighter than that counterpart. But again, if you weigh close to 250, I would walk a ladder that's rated for 250. A single ladder is a non-self-supporting ladder that's not adjustable in length, consisting of one section. The type of ladder is rarely used anymore because extension ladders are usually used instead. A lot of single ladders are made of wood. And if a homeowner has a ladder, just as an FYI, I've been to so many inspections where I pull up and I get out, I talk to them before I start setting up equipment. I go talk to whoever's present. And a lot of times, if the homeowner is there, they'll say, hey, don't even worry about getting your ladder off. I've got one out back. If you own your own company, you can make a company policy that you only use your equipment. That way, instead of offending somebody, you can just say, well, we can't do that. It's a company policy. I just use my own equipment. And your insurance company will love and thank you for not putting yourself at risk on someone else's equipment. Because if you fall off a roof after using a homeowner's ladder, it's possible they cover you for workers' comp. It's possible they do not because you're not using your own equipment. So I would encourage you guys to carry a ladder with you. Don't ever expect one to be on site. And even if there is one on site, just don't use it. There's no reason. You can't attest to what that ladder has been through or how old it is and the current condition of it other than visually. Multi-position ladders, which are kind of everyone's favorite nowadays. These versatile ladders like the Little Giant brand, Werner's got their own. There's a bunch of different brands. They can transform into step ladders, extension ladders, stairway ladders, and scaffolding positions. They're popular because one ladder serves multiple purposes, though they tend to be heavier than single-purpose ladders. The image above, or the image shown on your screen, is a Little Giant ladder, 26 feet, aluminum, 300-pound weight capacity, and it weighs about 50 pounds. For reference, a 24-foot aluminum extension ladder is somewhere around 30 pounds. So it's definitely heavier than its extension ladder counterpart, but man, I'm a homeowner, and at my house, I have one because it's just phenomenal. They fold up, and you can kind of put them away. So if you're comfortable with how much heavier they are than normal ladders, they're definitely so good for every type of purpose. Attic ladders are a common type of ladder. Obviously, you guys have run into them, I imagine. Some inspectors carry compact, lightweight folding ladders specifically for attic access through scuttle holes where a full step ladder won't fit or it's awkward to maneuver. And then telescoping ladders use a pin system to telescope into variable lengths. It's much more portable than an extension ladder. It's often preferred over that design for indoor applications. Inspectors should be aware that accidents have happened due to failure of the pins, which can be difficult to detect in advance. Some inspectors refuse to use telescoping ladders for this reason. I am one of those inspectors. Every single rung has 2 failure points. That's just my way of looking at it. Has it ever failed on me? No. I've used them plenty of times, and many, many times, to be honest with you. I've used them to inspect attics. They're very convenient in terms of portability, but again, my own skepticism is there's 2 failure points for every rung on the ladder, and that's just a lot of potential failure points. And when they get older, some of those pins tend to stick a little bit, and so they don't always lock in unless you're like paying really close attention to do that. So just use caution whenever you're selecting your ladder type. I would say a telescoping ladder, it's the cheapest version, and it's definitely the most portable. You can get one for like $90 on Amazon, but I'm just not a huge fan of them because of how many failure points you can have. But again, if you're inspecting on a budget and you want to, risk it for $90, I wouldn't say it's a tremendous risk. They're supposedly rated for 300 pounds, and as long as you get everything clicked in properly, $90 is a great solution that you can stick in the back of literally any vehicle ever. So I'm not selling you on using them because I don't like using them, but it is an affordable option. Safety guidelines. Before we move on, I just wanted to talk about this 4-to-1 rule for extension ladders. For every one unit, for every 4 units in wall height of access, so for every 4 units up to wherever the ladder is touching the wall, there should be 1 unit away from the wall. So units can be anything you want it to be. For us, it's usually feet because we use the imperial system. So for every 4 feet in height, you want 1 foot away from the building. So a 75.5 degree angle, it's not necessarily something that you need to measure, but you can kind of get an eye for it. You shouldn't be so far back with the feet that you're leaning heavily on the building, because what can happen is the feet can kind of kick out from underneath you, even though they have anti-slip safety shoes and feet. And in grass, you can kind of flip those things down and there's spikes on there. So there is safety precautions in either direction, but if it's set up too steep, as you're climbing up, you'll definitely feel it, because it'll feel like you need to hug real close to the ladder to feel like you're not going to take the whole ladder with you like a bad kids movie and fall backwards. So 4-in-1 rule, that's a OSHA regulation type thing, and it's a good safety guideline. So again, if you fall off of your ladder and get injured, it's very possible that if everything stays as is, if the ambulance comes or somebody's documenting what's going on, if you don't have your ladder set up correctly, it's a huge liability. So something to pay attention to. That 4-in-1 rule is just a rule of thumb, always good to pay attention to. And I would also add to tie your ladder off whenever applicable. So if you're leaning on an outside gutter, I would have a way to try to not do that, but also I would tie off to a gutter spike with using a bungee cord or something like that to make sure that the ladder doesn't go for a ride on you. So safety guidelines, 3-point control is a little bit different than 3 points of contact. So OSHA's kind of a 3 points of contact type of thing. So some people are familiar with 3 points of contact, but 3-point control is a little bit different. It's a method that involves using 3 or 4 limbs distributed over 3 or 4 locations for reliable support. So keep your center mass between the 2 side rails, 2 hands holding the ladder rung or side rail, and 1 foot on a ladder rung. You stabilize yourself using both feet in 1 hand or 1 foot in both hands. It's a lot safer for an inspector to grab a horizontal rung rather than a vertical side rail. And in these instances, sometimes comfortability can be your enemy. Same thing as like skydiving. There are not a lot of skydiving deaths, believe it or not, but the ones that they do have are usually from experts who are trying to push the limits and not be careful enough. So similarly, with ladder safety, if you're brand new to ladder safety, sometimes people are clinging on so tight you can barely get them off of it. But once you start to gain comfortability, you start holding onto those side rails. And if your foot slips, a side rail is not going to do you a whole lot of good. And you may end up with a nasty hand wound, because sometimes those can get burred and catch your hand. So you want to focus on keeping your hands on the rungs of the ladder as you're going up, and keeping that 3-point control method active the entire time you're going. And again, that 4-in-1 rule, a 4-to-1 rule, you're looking at it there. Also, having 3 feet above, I think 2 feet is required, but I know 3 feet above, 3 rungs above the access point is definitely good for comfortability. There's also some side rails you can buy. If you message me, I can link you what those are. They make the ladder a good bit heavier, but it extends the side rails without extending the rungs up, because the trick is you don't want to go too high, because then you're having to step around your ladder, and that's a little bit sketchy. But you won't want to go too low, because stepping over your ladder without having something to grab onto can be a little bit sketchy as well. So, quick tips for ladder placement and safety. Think safety first, as you should always do. Climb ladders that are rated for your weight. Ensure that the ladder is, and there's a temptation, by the way, to not climb a ladder that's rated for your weight, because a lower rated ladder is going to be less expensive. But I would encourage you, engineers do tend to over-engineer things, but I have heard of ladder failures, especially as they start to get up the years in age. So it's possible to, when a ladder is extended out, that ladder can pop loose and fold in on itself while you're on it. And again, never happened to me, but I know enough people after 15 years that I'm I know people firsthand that have had that happen to them. So climb a ladder that's rated for your weight. Ensure that the ladder is properly leveled on solid ground. Make sure that the ladder is at the correct angle to the wall using that 4-in-1 rule. 4-to-1 rule. Pay attention to what the ladder is leaning against, as it's easy to mark siding or damage guttering if you're not careful. If there's plastic gutters, I would definitely say be super careful setting up against a gutter. And also, just as a liability thing, take pictures of the gutter where you set up, before you set up and after you set up, or before, during, and after. Just again, as a liability thing, just to make sure if there's any damage on that gutter already, you're not getting called out for extra damage to that gutter. Consider using an electrician's ladder that steps are made of non-conductive fiberglass that will protect you from shocks. Again, much heavier, but also not conductive. Properly stage the ladder according to standards. Grasp the horizontal ladder rungs and not the vertical rails. Use the horizontal power hand grip. Grasp rather than simply make contact. Again, I can fall into this because I've been doing it so long. I can make the mistake of just touching the rungs rather than actually physically grabbing them and making sure. But again, it just all safety requires intentionality, right? So distribute your weight among the 3 or 4 locations. And that's a big thing. Don't lean on a ladder. Don't be shifting your weight around too much. It should be going straight up and down. If there's something that you need to take a picture of that seems close by, but it's just a little bit out of range, or you can't get a great camera angle, take the time and move the ladder. It's that simple. To determine whether your ladder is placed safely and properly, follow these tips, courtesy of InterNACHI member David Lane of Texas. Lean the ladder against the building, look at the ladder's feet, and draw an imaginary line between them. Put your toes up to that line, stand up straight, and hold your arms straight out in front of you. The ladder rung should be just beyond your reach, just beyond your reach. If you can touch the rung, the ladder's too steep. You got to move the feet back and repeat those steps. If the rung is several inches beyond your fingertips, the ladder is too shallow. This is also hazardous because the feet can slip backwards when you're on it, causing you to fall. Move the ladder close and repeat the procedure. This is a simple process that takes 5 seconds and ensures ensures that you're about to climb a ladder that is properly pitched. And just pay attention to where you're setting up as well. Grass to me is always feels much better. Concrete is sketchy, if for no other reason than if you fall off of that thing, you can have some bad issues. But also the feet can tend to slip a little bit on concrete, even there's just a little bit of moisture. And if it's an older wood or composite deck, you're almost definitely going to have some algae buildup on it, especially if it's like in the back of the house and there's a lot of trees back there. You can end up with algae buildup, and that thing can get slick really, really quickly. And you may not notice it right away, but as you start to put tension on those feet because you're climbing up the ladder, those ladders flex a little bit in the middle, and that puts backwards tension on those feet. It wants to kick out. So if there's anything slippery underneath those feet, it can definitely slip out, and that's super sketchy and very dangerous for not only your safety, but also for damage to the siding and potentially a window and other things like that. So roof inspection tips. When inspecting the roof covering material during a home inspection, describe and report on the type of roof covering material. Describe and report on the visible condition of the roof covering. So you can I know for my reports, I kind of have a scale that it falls in one of a couple different conditions. You can do good, fair, or poor. You can kind of develop your own for your own report, but you want to kind of have a way of correlating the roof. Even if you say the roof is in good condition, in my report, it's pretty detailed in terms of what that means. Why am I saying it's in good condition? Why am I saying it's in excellent condition? Or why am I saying it's in poor condition? Visually inspect and report on the observed flashings. Check the roof drainage, gutters, and downspout systems and components. Check for any overhanging tree branches that may have adverse effects on the roof covering. And that includes something that seems like it's a little bit close to the roof covering, maybe something that seems cracked that might fall soon, or in a lot of instances, if there's actual overhanging tree branches that are coming into contact with the roof, even small amounts of movement over and over and over again, you'll end up with what they call tree rub damage. It's very different than tree impact damage. It wouldn't be covered by your insurance company. It's a maintenance issue, and it can be just as detrimental to a roof as a tree impact from an acute event. It's a cumulative thing where it sort of rubs down the shingles and starts to degrade them, and eventually it can wear a hole right through the shingles. Inspect all roof penetrations and report on any indications of observed defects at underlying roof deck structure. For example, a sagging ridge or sagging deck sheathing beneath or between rafter boards. And that can be very common in the instance of like rafter spacing that is too great. So I'm guessing I'm in good company talking about span ratings and things like that of underlayment. So of plywood or OSB sheathing, there are span ratings for those things. And typically on a roof, you want to see 16-inch rafter spacing. Now, again, if it's timber framed or there's some other things at play, it's possible to have more than that. But a good rule of thumb on a residential home is 16-inch rafter spacing. Well, if you have greater than 16-inch rafter spacing, say 24-inch rafter spacing, and you don't have sheathing that's rated for that span, then you're going to see deflection in that sheathing and it's going to start to sag in between the rafters. So that's something you want to report on. Inform the client of the method used to inspect the roof, right? So if you use a drone, tell them I used a drone. If I used a ladder and got up there, tell them I got up there. Or if you're on the eave with a ladder or with binoculars, you get the point. Tell them what you did to gather the information that you gathered. Inspect all roof components in their flashing. Inspect the boards and components at the roof edges and eaves, such as rake boards, soffits, and fascia boards, and check and report on any observed indications of major defects related to the roof covering systems, and components that may be seen from accessible areas under the attic of the roof, areas of the attic under the roof, including as signs of sheathing problems, indications of prior or active moisture intrusion, or damaged structural components such as cracked rafters and damaged or modified roof trusses. For determining whether something is active versus prior, I would always encourage you to have a moisture meter with you. And if you're in the attic space and you see a stain on the decking, put your moisture meter on it. Obviously, be aware of the relative humidity and the other. Take a test area where it seems dry and then put it on that area. It's also important to understand what you're not required to do as a home inspector. You're not required to walk on the roof surface. You're not required to report on the future life expectancy, which is probably the main question that you're going to get, which I don't ever answer it.
Hey, Matt.
Yep.
Hey, what slide are we supposed to be on?
We're on this one.
What's the title of it?
Roof inspection tips.
Okay. There's a couple people are saying the slides aren't sliding.
I'm just talking through it. There's notes kind of with each slide. So these are just roof inspection tips. I'm not sure why it's a guy sitting on a ladder and two guys on the same ladder and all these things. That seems like a ladder safety slide, but
okay.
These are the notes.
I'm just addressing the concerns in the chat and
oh yeah. No worries. Don't worry, guys. I didn't move past you.
All right, proceed.
You're not required to warranty the roof. You're not required to inspect ancillary components such as antenna, solar panels, and satellite dishes. Again, my advice to you would be to address that those are there without speaking to them, because it's not your job to inspect those things. Report on underground downspout pipes or termination discharge points, or inspect the roof structural framing system and components when they are not readily accessible. So if you can't see something in an attic space, you're not required to report on it. Hopefully that goes without saying. Inspect the roof covering materials only. Again, we're not going to get too deep into all these videos. I'll probably just skip through this and go to the next slide. Roof covering materials. Home inspectors should report on the roof covering or the roof covering material that they observe during the home inspection. They should not report on the roof system, roofing, or roof assembly, the components of which are not readily observable. Components of a roof system or roof assembly are not readily visible during visual-only inspection. So what this is referring to is there are parts of the roof, like the roof deck, the load-bearing components, the trusses, underlayment, especially substrate, fasteners, thermal barrier, vapor retarder, insulation, ventilation, and the roof covering. That would be a roof system or a roof assembly. A lot of those things I just listed are not visible during a visual-only inspection. So you can't necessarily see the underlayment. Now, if you want to pick up the roof covering material at the eave to see, again, there's nothing saying you're not allowed to do that. You just want to do so with caution. If it's a very brittle material, you don't want to cause any damage. So can you see the underlayment? No. Can you see the fasteners? No. Can you see the decking? No. So it's possible to see those things, but you're not required to report on it. You're not required to report on it because you can't necessarily see it. Roof covering is a term specifically used and defined in the International Residential Code and Building Standards. Roof covering is the covering applied to the roof deck for weather resistance, fire classification, and or appearance. Since the roof covering is layered, not all of the covering material is visible during a home inspection. There are other terms that refer to a combination of the components used together to form a complete assembly. A system is made up of smaller parts, an assembly is made up of smaller components. And when the parts or components are not readily visible, they're beyond the scope of a home inspection. The focus for a home inspector should be on roof coverings. A variety of roof covering materials may be installed on a house or building to be inspected, such as asphalt shingles, clay tile, concrete tile, built-up roof, wood shingles and shakes, and metal roof panels, and also low-slope roofing materials. You could have an asphalt shingled roof with an EPDM flat section, and you can even have different types of roof covering on the same house. If they decide to upgrade one slope of the house because it seems to be in worse condition, like in our hemisphere, if it's a southern facing slope, it can get weathered a lot faster than a northern facing slope. So somebody might say, well, there's not a whole lot wrong with the north face. Why don't we just replace the south face? And while we're at it, we're going to upgrade the shingles. So you may end up with a front slope that's 30-year laminate shingles and a back slope that's 3-tab shingles and a flat porch area that's EPDM or rolled roofing or built-up roofing. So those are all roof coverings. So built-up roofing is a common roof covering for houses and buildings with relatively flat roofs and made up of 2 or more layers of felt cemented together and surfaced with a cap sheet, mineral aggregate, smooth coating, or similar surfacing material. As a home inspector, you'll only be able to observe the top exposed roof layer. Remember that just about everything, every component and system is limited and restricted in some way for the inspector during a visual-only home inspection. So stick to inspecting and reporting on the roof covering. Roof slope and pitch. Both pitch and slope indicate the incline of a roof expressed as a proportion of the vertical to the horizontal. This section describes both roof slope and roof pitch, the differences between them, as they're not the same. Some people use those terms interchangeably, but they're not the same. Slope affects how roof systems are installed, including dictating which type of roof covering material can be applied. The illustration shows a simple gable roof and the general relationship between rise, run, and span. Roof framing is a practical application of geometry, and roof slope is based largely on the properties of a right triangle. In roof framing, the base of the right triangle is called the run. The run is the distance from the outside of the wall's top plate to a point directly below the center of the ridge. The vertical leg of the triangle is called the rise, which is the distance the roof rafter board extends upward above the wall's top plate. Slope is the incline of the roof expressed as a ratio of the vertical rise to the horizontal run, where the run is some portion of the span. The ratio is always expressed as inches per foot. Slope ratio, a roof that rises 4 inches for every 1 foot or 12 inches is said to have a 4 and 12 slope. If the rise is 6 inches for every 12 inches of run, the roof slope is 6 and 12. The roof slope can be expressed numerically as a ratio. The slope ratio represents a certain amount of vertical rise for every 12 inches of horizontal run. So one number changes, the other doesn't. It's always 12 inches of horizontal run. So 4 and 12 can be expressed as a ratio, 4 with a colon, 12. That's a ratio. A 6 and 12 would be 6 colon 12. The triangular symbol above the roof line is in this architectural plan provides information on the roof's slope. So right there you can see they drew a little right triangle, and that's an 8 and 12 roof slope. Slope is expressed as a ratio in inches per foot. Now, pitch is the incline of the roof expressed as a fraction derived by dividing the rise by the span, where the roof span is the distance between the outside of one of the wall's top plate to another. Pitch fraction, right? So historically, the word pitch meant the ratio between the ridge height to the entire span width of the building, or the ratio between the rafter length to the building width. The ridge was typically the middle of the span. This is no longer the case in modern building practices. The ridge can be placed anywhere in the span, from directly in the middle to either span endpoint. A roof that rises 8 feet over a 20-foot span was said to have a 1 to 3 pitch. If the rise is 4 feet over a 24-foot span, then the roof pitch was said to be 1 to 6. The pitch can be expressed numerically as a fraction. The pitch fraction, which is different from the slope, represents a certain amount of vertical rise over the entire span. For example, if you have a roof with a rise of 4 feet and a span of 24 feet, the pitch is 1 to 6 pitch, which can be expressed as the fraction 1 over 6. A 12 to 24 pitch can be expressed as 1 over 2. As I said, the term pitch and slope are often used interchangeably, which is not correct. They don't mean the same thing, and the slope provides more valuable information than pitch, as defined here. Using this illustration and information we learned about slope and pitch, we can see that a 212 slope can be expressed as a 1 over 12 pitch. Assuming the span is twice the length of the run, 1 to 12 pitch, assuming the span is twice the length of the run. If the slope is 412, the pitch for the 24-foot span is 1 over 6. If the pitch is 1 over 3, the slope is 812. Remember, the slope is expressed as a ratio and in inches per foot, which is a much more useful thing. I would say just stick to that. Don't worry too much about the pitch. Always just use that slope measurement as a ratio. The pitch is a fraction derived by dividing the rise by the entire span. The slope of a roof affects the surface drainage of water and can determine the type of roof covering material that should be installed. A lot of people use the terms residential or commercial roofing. I wouldn't encourage you to use those because a residential roof can have low slope roofing material. So if you talk to a shingle manufacturer or a roof professional, they would call them low slope roofing materials, which include EPDM, TPO, all those single ply membrane type materials. Modified bitumen, built-up roof, all those. Asphalt shingles, clay tiles, all different types of tile, metal roofing that has exposed fasteners. Even in a lot of instances, if it doesn't have exposed fasteners, those are steep slope roofing materials. And again, that can sound odd because you say, well, 3 and 12 is not really a steep slope, but it is above 212. And I'm sure we'll get into this at some point, but if you read the International Residential Code, the guideline is from 012 to 212 is low slope roofing and requires an impermeable membrane to cover the roof because water will not drain off fast enough. So if there's exposed fasteners, the water will find a way to get in. Steep slope roofing materials can be applied above 2, but if they're between 2 and 4, so anything above a 212 up to a 412 needs to have additional considerations such as a double layer of underlayment, which is achieved by rolling out the 36-inch roll of underlayment and overlapping it more than you normally would so that you achieve a double layer at any given point. Or you can use something like an ice and water shield, like a self-adhering impermeable membrane underneath. And that's up north of the Mason-Dixon line. A lot of times what they do is rather than even using a traditional underlayment, they'll use an ice and water shield on most of the roof. So asphalt shingle roofs are designed to shed water and not meant to serve as a waterproof barrier. So water shedding versus waterproof. Asphalt shingle roofs are not designed to be waterproof. They're designed to be water resistant because they're designed to shed water off of them. It's literally designed to divert water down to a drainage system and take the water away from the structure. It isn't designed as an impermeable membrane like a low slope roofing material is. The slope of a roof affects its ability to shed water and determines the limits for using asphalt shingles. Like we talked about, 412 to 2112, you can use a standard application method. Asphalt shingles may be used on slopes from 212 to 3.912 if special low slope application procedures are followed, like we talked about. So to summarize, pitch and slope don't mean the same thing. Don't use them interchangeably. I would encourage you to forget pitch for right now unless you're a builder. Just use the slope. Slope is a ratio measured in inches per foot. The pitch represents a fraction, or the pitch fraction represents a certain amount of vertical rise over the entire span. So just stick with those easy numbers. You can kind of see up there, having that 812 is an easy way to correlate that. So let's talk about roof styles. You can see a gable in the upper left corner. Those are one of the most common styles. They're very easily identified. They have two slopes. A lot of people call them up and overs. The ridge extends the length of the home. the lower level edges of the roof are called the eaves, and the sloped edges are called the gables or the rakes. We use both terms. So what you're looking at in that upper left photo, that elevation of the home that is the front of the home, that is called the gable end, and then those angled runs, which are essentially the hypotenuse of those two right triangles, left and right, that fascia board facing you, that's called a rake edge. And then if you look on the left side of the house where the gutter is hung, that's called the eave. A hip roof. There's two types of hip roofs, and both have four slopes. The basic hip roof has a level ridge, but the ridge doesn't extend all the way to the exterior walls. Instead, there are hip rafters that slope diagonally down to each corner. The hip rafters all meet to form a point at the peak of the roof. A mansard roof. Mansard roofs were invented by the French when owners were taxed by the height of the building as measured to the roof eave. So they started putting the roof eave, but then having it go up and having dormers in the side where you have livable space that's literally just on the other side of that, what looks like a wall, but it is roof. They're short, steep roofs installed around the perimeter of what's usually, but not always, a flat roofed building. Some of these roofs are nearly vertical, and this can cause installation problems, which will vary with different types of roof covering materials. So the ones in the photograph in the lower middle, those are 3-tab shingles. As you can see, if you have an inspector's eye here, you can see a lot of the corners popped up there. It looks like they did use a stair-step method of installation, and so you can kind of follow those corners up diagonally. They're all popped loose because they didn't ever get the chance to adhere properly, and you can see the ones over that right dormer window are blown off. There's damage there. There are over 2112, there are hand sealing requirements by certain manufacturers. So it doesn't look to me that those were hand sealed. And even if they were sealed, there is expansion and contraction that can happen, and those corners can get popped loose, but that's not something we're going to talk about right now. Sorry, I was looking at the questions. I think we'll catch those before a break. So keep your questions coming, guys. We will address them as we go. Flat roofs, those have very little slopes. A typical slope would be 112. It's not supposed to be less than a quarter inch to 12 in certain scenarios with certain types of roof, or it may just be flat with drains or scuppers and things like that. So flat roofs, they may drain over the roof edges or through scuppers installed in a parapet wall around the perimeter. Flat roofs are low slope roofs. Low slope and steep slope roofs have different requirements. So again, low slope roofing material, less than 212. Steep slope roofing material, over 212. That's a good line of demarcation, is a 2 and 12. Shed roofs have one slope. Because shed roofs are often used for additions, one potential problem area is along the upper edge of the shed roof where it ties into the wall of the original home. That's a huge flashing problem. We'll talk about that. As you can see in that lower right picture, that is a shed roof. It looks like there's a gable roof on the main portion, and someone says, well, it's very complicated to tie in a sloped roof into a wall, so I'll just use a shed roof. Well, where that roof to wall transition happens, roof to wall transition is an important area for you guys to just pay attention to all the time. That's just very commonly a problem, and you'll see leaks on the inside at that transition. There's usually like, four-season porch with a cased opening into a dining room or a kitchen or something, and you'll have some stains somewhere in that ceiling. And then it says freeze damage may occur on the lower roof edge. That's very true, because if it's a lower slope, you may end up with ice dams and things like that. We'll talk about a couple more roof types. A gambrel roof, they're usually associated with barns, but they're certainly not uncommon on homes. They have two slopes, each of which change the slope or slant in a convex manner. So it almost looks like it has three ridges. There's your main ridge. It goes down at like a lower slope, maybe a 4 and 12, and then it takes a dramatic drop down to like an 18, 12. And again, most people call them barn roofs. The point at which the roof changes, so that second quote unquote ridge, it's not actually a ridge, and it doesn't get shingled like a ridge, hopefully for obvious reasons. But as that slope transitions down, there should be additional flashing, which is true in a concave or convex situation. Whenever there's a slope transition like that, there needs to be flashing where those roofs change the slopes. A bonnet roof, Those have a change of slope but are concave, the opposite of a gambrel. So, like we just talked about, instead of a gambrel that looks almost like it could be round, so it drops from a lower slope down to a higher slope, which creates a convex surface. You'll have a higher slope, like an 8 or a 10-12, that drops down into a lower slope, and that's a concave slope transition. Either way, it's called a slope transition. Either way, it needs flashing. And a butterfly roof is definitely seen less often, but you can occasionally see them. When you see a home with a butterfly roof, look closely at the ceiling and floor beneath the low point in the roof. The house in the photograph, forgive me, I don't see, I see notes for a slide, but I don't actually see a butterfly roof in the slide. So I'll skip these notes. But in any case, Google what a butterfly roof looks like and definitely pay attention. It ends up being lower in the middle, and water can tend to pool up there. And then you'll, for obvious reasons, potentially get a leak. There's clearly flashing requirements there, but the whole installation process is just vastly different than your common roof. So we'll talk about roof features now. So clerestory. These photos show roofs with clerestory windows. Although the term clerestory refers to the position of the windows, it also generally describes their position as incorporated into a shed roof. Sorry. In other words, clerestory is commonly used to refer to the combination of roofs and windows. Clerestory windows should have adequate clearance between the sills and the roof below in areas with heavy snowfall. This home doesn't and is more likely to leak. They should also have proper sidewall flashing. Cupola. Cupolas are small structures built into the peak of a roof, often to provide light into the area below, sometimes just to provide ventilation. The inspection concern is the roof framing supporting the cupola. Although the framing will typically be hidden behind interior wall covering materials, look for signs of movement such as cracking, right? Other vulnerable areas are head wall and sidewall flashing, all to do with the cupola. And you can see the middle top photo is technically a cupola. And then there are such thing, there are smaller cupolas that are very, very typical. And we'll kind of keep going here. So conical roofs, some people call them witches' hats. They're often used to cover towers, as you see in that middle bottom photo. The first photograph shows a conical roof that is actually a series of tapered flat roofs. Creating a series of hips, installing around conical roofs requires special roofing techniques to get the shingles to lie flat, especially near the peak. Inspecting these roofs closely is difficult, if not impossible, without special equipment. So get as close as you can. Again, on this particular one, you could get pretty close to those inside sections of that roof, and you can get a good idea of the installation of the roof just from the sections that you can see. Inspection concerns include flashing at the round sidewalls in areas which conical roofs intersect with roofs of other shapes. Specially shaped crickets or flashings may be needed to provide long-term protection against leakage. One of the crickets is circled in red, it says, but again, I don't have a red circle here, but you can see on the middle photo, there's a special type of flashing with a small cricket. You're going to need special consideration whenever you have a conical roof that intersects with a normal roof. Because it has so many different angle changes, you're going to have a very specialized cricket. These areas of intersection, which are difficult to see because they're on the backside of the roof, often collect debris such as leaves and sediment. That debris holds moisture against the roof and flashing. This is not just true in conical roofs, but any roof flashing or any roof transition. If you have a lot of debris, it holds moisture like a sponge, and it can hold moisture up against these roofing materials that are not designed as waterproof. They're water resistant. And so you can basically start to erode the roof. You can corrode roof fasteners, and it's just not good to hold water up against the roof. So the areas of intersection are difficult to see, and they're also a weak point. If you can't confirm the condition of the roofing on the backside of a conical roof, you need to disclaim it and recommend an inspection by a qualified roofing contractor. A contractor may need to hook a ladder over the ridge in order to get a high enough on the roof to see the backside of a conical roof clearly. That's especially true when the roof is covered with fragile materials like slate or tile. Dormers are projections built into the slope of a roof. You can see dormers here, and that lower right photo is a dormer. And technically, up in the upper right photo, you can see there's a conical roof right in the middle. And then you can see dormers. There's three dormers off to the left. They have hip or shed roofs intersecting. Inspection concerns are valleys, head wall, and sidewall flashing. So again, the dormer in the upper left photo has a shed roof, and you can tell that there would be a roof to wall flashing situation there that you really need to pay close attention to. Again, that one's got all kinds of windows there, so the flashing is going to be critical. And again, that sidewall flashing where the roof to wall intersection is on the slope of the roof, that's a step flashing situation. Looks like in that particular photo, they're using cedar or some kind of wood siding, and that's going to act as the counter flashing. So, there's two different scenarios. There's instances where there's normal siding, like hardy siding or vinyl siding or wood siding. In those instances, there's step flashing required, but then the counter flashing is essentially, hopefully, some kind of a flashing tape underneath the siding, the house wrap, and then the siding over top of that. That's all kind of acting as a counter flashing. That's a little bit more difficult to inspect because the flashing is not exposed. Other roof combinations and styles, you'll see several roof styles combined in one home, and sometimes you'll see roof styles for which there's really not a name, which I've seen. The structure above is a dormer roof, the structure above is a dormer because it's a projection built into the slope of a roof. The structure below is a second story since the exterior wall is continuous from the foundation to the roof. The only limitations to the number of styles possible are the human imagination, the laws of physics, and the depth of the homeowner's pockets, which is a big consideration. Each different style of roof and roof feature has its weak points. Once you learn what those are, you'll know where to expect problems. With all roofs, weak points are places where the roof covering material changes, places where the roof changes direction or slope, places where the materials are used have a relatively short lifespan, roof penetrations, and portions of the roof that lie in the drainage path. Going to the next slide here, AJ, do you want to stop for a break?
Yep, let's pause here for a break, answer some questions. We'll be back on topic at 7 o'clock.
Awesome.
All right, so questions. We have a few. Start with James. He asks, very few homes in my area have gutters. What would you tie off to in this case?
Unfortunately, you can't tie off. What I would recommend is they have ladder standoffs, they call them. Some people call, I'll say it this way. I would prefer not to see somebody use bullhorns, but that is one common one where you have the ladder side rails. You'll have a bracket with something that comes off sideways and then forward, and it has rubber tips on it. The reason I'm suggesting that you would use that because that would help the ladder to not move around. The only problem with those is I just see them very often where those rubber tips wear out because it's a hollow metal tubing that's used in an L formation away from the ladder, and the ends of that metal tubing a lot of times cut through that rubber standoff protector, and then you'll end up with people with tennis balls on them and tape and all this stuff that doesn't look very professional. And if you don't use that stuff, as soon as that metal cuts through the rubber, when you stand off on the shingles, you're not crushing the gutter. You're in pretty safe shape in terms of the ladder not blowing off the roof, but you can damage the roof that way. There are standoffs that are a little bit better that are sort of V-shaped, and they plug into two rung holes and they come off forward, and they have long rubber sleeves that go over them. Those ones are fantastic. They add a lot of security without having to tie off. Again, it's not impervious to going off the roof, but if you have something like that, use a ladder standoff. You can even just Google or Amazon ladder standoffs. And again, like everything else, if I don't cover it specifically in terms of where to get something or what it looks like, just shoot me a text and I'll text you or email you back a couple links for those to purchase.
Awesome. Thank you, James, for your question. Daryl asks, your thoughts on downspouts discharge onto lower roofing system. Some newer homes, the soffit is not visible. So
I'm not sure on
downspout discharge.
I'm not sure on the second part. Downspout discharge onto the lower roofing system almost always causes a problem. One thing that's actually a huge problem, like a huge disclaimer or sorry, huge defect would be if you have an upper roofing system, like looking at the roofing system on the upper left, if you can see the screen right now, I'm just going to use I thought I was going to use thought there was a way to turn the laser pointer on with one button. In any case, if you look in the upper left photo in that last slide, you can see the downspout coming off the left side of that dormer out onto the lower slope. One thing that is an absolute no-no and should never be okay is if that downspout discharges lateral. In other words, if it discharged to the left to kick it right into the sides of the shingle, that's always a no-no. I would always call that out as a potential leak. In this case, it looks like it discharges right onto the roofing system. Again, this is not appropriate. I don't think it's good. The only problem is the only way to fix it would be unsightly because the right way to fix it would be to add extensions to the bottom of the downspout until it gets down to discharge directly into the next gutter. So as you can imagine, there would be, in that case, at longest, probably a 13 to 15 foot section of downspout laying on the roof. It's not preferable because there's no way to brace it. And so if it's catching by the wind, it's rubbing the surface of the roofing material off. The other way would be to discharge it into some gutter sections that may turn down to like a 45, extend down into that upper portion of gutter. Either way, it's not a there's just not a great drainage system for dormers that are projecting from the roof system. There's always trade-offs. There's a design trade-off because you want more light in the home, so I want a dormer, but the roof drainage really should not be discharging directly from a downspout onto a lower roof surface unless that roof surface has ice and water shield underlayment or any other impermeable layer under the shingles. But again, maybe clarify later. I'm not sure what the second part of that question meant. Sometimes the soffits are not visible. You just talk to us later on that.
Some architectural shingles rated by wind speed ratings, rather expected year warranty.
Yeah,
Most
yeah.
are
He's saying
35 years.
some of them they don't say 35 year or 40 year. They say rated for 135-mile-an-hour wind or rated for.
Is it worth it?
Yeah, yeah. The wind ratings are legit. I mean, they use ASTM testing to check them. So in some areas, like special coastal regions with certain wind exposures, the rating of the shingles is important. I would say what might be slightly more important than that is I don't want to say more, but maybe equally important is the fastening method. In high wind areas, areas that are like coastal areas that are susceptible to high winds, you're required on a laminated shingle to use 6 nails instead of 4. So I'd say they're worth it, but how well they're installed is always like a lesser shingle can outperform a better shingle if the installation method is better. So yes, they are worth it. Just as a yes or no answer, yes, they're worth it, but ensuring that you have a good roofing contractor is the most critical component of having a new roof system.
Should dormers and or high shed roofs have gutter systems?
Yeah, for sure. And again, like that lower right photo, you can see that there's no gutters on that. So it would be really difficult to get something. Now, what would I personally do? I'd probably end up adding some ice and water shield at the end of that valley in near that sidewall and everything, and then allowing the downspout to discharge onto the roof. But I'd make sure that it comes down and shoots down slope on the roof, not just discharges to the left or right. because there's just not a perfect solution when a dormer's popping out of a roof. Again, it's great aesthetically, but yes, they should absolutely have gutter systems because you can imagine if you're diverting the water the way that you want it to go, then you have some control over the flow of that water. In the instance of that lower right photo, all of the rainwater is flowing off of that roof. And again, if you can imagine, like some people don't think in terms of load path or water path, but the water of this roof is going to be running down that slope, catching in that valley, and running to the end of that valley to run down. Well, any of the water that's running down slope is going to be falling off and splashing that water to run laterally. So there's almost definitely going to be a leak at some point. Again, maybe not. Maybe they did an unbelievable roofing job and there's no problem, but you never know there's a problem until there is one, and then it's usually a big problem.
Thanks, Daryl, for your question. Rich asked, or he says, I saw a house recently that had concrete tiles installed on top of asphalt shingle roof. In addition to the added weight, what other concerns would you have about this situation?
I think the added weight is probably the main concern because if you're ever switching from one roofing system to a concrete tile roofing system, you're going to want to get a structural engineer involved to sign off on whether or not the framing is adequate to bear such a load. And in most cases, it's not. So I would say the added weight is probably the biggest concern. I think if I'm remembering correctly, there are materials like that that are perfectly, like even metal roofs, they're appropriate to install over one layer of asphalt shingle roofing. I would also, I guess I wouldn't be concerned because depending on the tile and depending on the jurisdiction, it's possible to lay it down right over top. Normally, if you're going to lay a tile roof on top of an asphalt shingled roof, you'd want to install batten strips so that there's some airflow underneath. So like there's ventilation behind the actual roofing material. That's not common. Like asphalt shingles would never need batten strips. I don't even think you could install them on top of batten strips, but a lot of tile roofing does need it. So if you were going to retrofit, if you have an existing asphalt shingled roof, you need to run horizontal batten strips and then hang those tiles because some experts would say that tiles are very rarely installed, they're hung, if that's it makes sense as far as a distinction. Like vinyl siding is a good example of that. You don't install vinyl siding in terms of hammering it right down and making sure everything's nice and tight. You actually hang vinyl siding. So you don't install the nails all the way down because you want to allow for some movement. Very similar with a lot of tile roofing materials. You want to make sure that it's installed properly, usually on top of batten strips. Again, if it's a certain manufacturer or a certain jurisdiction with certain preferences, those can be concerns. But yeah, the biggest concern, to your point, is definitely the added weight and whether or not a structural engineer said, yeah, the framing is fine for that.
All right, and last question. Christopher says, when calling out kickout flashing, are you treating it as a defect anytime the kickout isn't at least 4 inches tall? I know several manufacturers that show a minimum of 4 inch height in their installation details, but in the real world, I almost never see a full 4 to 6 inch in the field. I'm curious on how you handle that. Do you report based strictly on manufacturer requirements, or do you account for typical field conditions when the installation is smaller but still functional?
I would, if I know who the manufacturer is, there's a lot of roofing materials that I, as a roofing expert, can visually identify, and I know, say it's a GAF or it's a CertainTeed or whoever the manufacturer is. If I can readily identify who the manufacturer is, or even if it's Hardy siding and Hardy has a sidewall detail, if there's any known specification, then I would call it out as not being tall enough. What I would normally do is call it out as like an observed thing, as like a maintenance condition, like something to pay attention to, so to speak, like a yellow light. I would say if it's not as tall as you think it should be, in the application is a big deal too, because it's like if there's a 4 foot roof slope and a wall that extends out 12 feet and the roof slope is say 412, am I really super concerned that it's not at least 4 inches tall? I'd be super grateful if they would just install a kickout. Like if anybody would install a kickout. But if there's not a tremendous amount of water, you got to try to envision what the condition is going to be in the case of inclement weather. How much water is really going to be running down that slope? And again, if it's a tremendously big slope, I don't really care who the manufacturer is. There's going to be a huge amount of water. And again, sometimes you'll have a sidewall right near where a valley's putting a bunch of water down. you're getting a lot more water there. Yeah, I would want something that's a little taller and something that's of a, if it's taller, I want it of a substantial gauge metal. I don't want some trim coil being bent in, crudely bent into a kickout flashing. If it's going to be 4 to 6 inches tall, I want to make sure it's an appropriate gauge metal that's not just going to fold over if it's overloaded with water. So there's a lot of considerations. I hate to always give these like it depends answers, but it does depend. If I know who the manufacturer is and I know what their requirements are, I'm going to put that in my report in my reference to this isn't tall enough according to that manufacturer. If I don't know, then I'm going to have my own feeling on what I think should be appropriate. And if I'm going to call it out, I'm just going to appeal to someone who's greater than myself. Like if I'm going to say it needs to be 4 inches tall or taller, I would like you to I would like you to reference why you're telling me that. If I'm buying a home and you say, "Hey, it's got to be at least 4 inches tall," my question to you would be, "Are you just making that up, or why are you telling me that?" And so I would include some kind of manufacturer specification in my report, or just say, several leading manufacturers dictate that kickout flashing needs to be at least 4 inches tall. So it really does depend on the situation whether or not I'm going to make a big alarm about that. But the bigger the slope that's running down along that sidewall, the lights just shut off in my office. Let me flip those back on, but I hope I've made my point.
Yeah. And just when you come back, just real quick, do you think splash guards create a problem?
They definitely can for the reason that I just said. A lot of splash guards are constructed using trim coil, which is a very thin gauge metal, and they can create problems because it's you just people do what they're told to do. So if a roofing crew is told to put a splash guard, they put one without thinking about why it's there. So again, it can violate its own reason for being if it's going to hold up water in a very adverse situation, a very inclement weather situation. There can be gallons and gallons of water pouring into this splash guard, and it's actually holding water back up onto the roof rather than what you might like to see it do is overflow. Just overflow. The kick out is still protecting but a house is not going to be watertight 100%. So there's just going to be certain situations that instead of preventing a problem, you're reducing a problem. You're saying, if something horrible happened, what can I do to make sure it's a failure without being a catastrophic failure? So yeah, I think they can definitely cause problems. So even though you're not required to talk about it, let's talk quickly about life expectancy. So the life of a roof really depends on local weather conditions, building and design, material quality, and adequate maintenance. Hot climates drastically reduce asphalt shingle life. I can tell you, I've inspected roofs pretty much up and down the East Coast in 16 different states. I've looked at roofs pretty northern Maine, southern Georgia, Alabama, and what a 15-year-old roof looks like in North Carolina or Georgia is very, very different what a 15-year-old roof looks like in Massachusetts, Vermont, or Maine. Home inspectors are required to identify and report defects observed during the inspection, but are not required to determine the cause of damage or diagnose the underlying condition. Again, you're not required to. If you feel confident to, you can speak to it. But according to the InterNACHI, the NACHI.org SOP, a home inspector is not required to determine the age of construction or installation of any system, structure, or component of a building. The inspection image above is of missing shingles blown off by high winds. It's specifically the middle photo, not the upper photo. The upper photo, I'm sure my notes will cover it in a second, but that is tree rub damage, what we were talking about before. It's very different. The edges are much softer, not torn, but rubbed away and degraded. The middle photo shows wind damaged shingles. Roofs in areas that experience severe weather, such as hail, tornadoes, or hurricanes, may also experience a shorter than normal lifespan overall, or may incur isolated damage that requires repair in order to ensure the surface life of the surrounding roof materials. All roof coverings, regardless of material, are susceptible to additional variables like weather, impact damage, and again, whether that's hail or I've inspected plenty of houses on golf courses with maybe some not so talented golfers on those courses. Environmental conditions, orientation, ventilation is a huge one. Insulation, structural issues, and installation defects. Installation defects is a huge one. So let's talk briefly about how each one of those variables affects a roof. And again, I know the slide's not moving, but I'm going to be talking for you just a second. Weather, right? We've all seen pictures of homes in Tornado Alley, the geographic region that lies between the Rocky Mountains and the Appalachian Mountains, with their roofs blown off. But it's not unusual to see weather damage in all areas of the United States. Again, I've seen microbursts and windstorms in Massachusetts that my home state originally, anyway. I've seen severe weather in Massachusetts tear up roofs. I've seen it again along the East Coast, south of the Mason-Dixon line as well. Sometimes severe weather damage will leave behind ripped shingles and dislodged tiles, affecting just one or two areas of a home's roof. But occasionally, there can be more widespread damage. It's a little bit easier to spot. Sorry. Impact damage is very common and most often caused by overhanging tree branches. It can also be inflicted by falling masonry and cracked tiles and shingles from people being on the roof. You can see in the inspection image roof damage caused by an overhanging tree branch in contact with the roof surface. Now, technically speaking, I would not call that impact damage. Again, tree impact damage has very different physical characteristics than tree rub damage. What you're looking at in that top image is tree rub damage that's happened from an overhanging tree rubbing by being blown around by the wind and being in contact with the roof simultaneously. It's just over and over and over and over, tons of little things. Again, if you took a tree branch with some leaves on it and rubbed it against a roof, is it going to cause a problem? No, but it will over the course of time. So you're going to want to call that out as in something in need of correction if there's an overhanging tree branch touching the roof, especially if it's already caused damage. But you could take an inspection photo like that as a sample photo, include it in your report, and say, this is what could happen to your roof if you leave that overhanging tree branch without trimming it. Environmental conditions. That category of rapid deterioration of the roof covering can be attributed to airborne pollutants that are prevalent in industrial areas, as well as from the acidity of pine needles breaking down on the roof surface. The orientation, right? The direction the roof faces can have a significant influence on the long-term condition of the roof. South-facing roof planes tend to show signs of overheating, particularly those with asphalt shingles. North-facing roofs and those in the shade tend to have more algae and moss-induced problems, both of which will shorten the life of the roof covering. So again, southern and western facing slopes tend to have more sunshine on them during the day. If they're asphalt composition shingles, they will definitely tend to break down much, much worse than a northern or eastern facing slope, whereas northern and eastern facing slopes can tend to build up that organic growth. The algae is kind of that black streaky look that you'll see on roofs sometimes that people are always asking, is there anything I can do about that? My answer is always yes, but I wouldn't. Just because a lot of harmful chemicals are sprayed on the roof, which can be bad for the roof long term. Even if they kill the algae, they can cause the oils in the asphalt to kind of leach out and end up drying it out really badly. And yes, John, I agree. 15 to 20 years for architectural shingles in Florida, and that's if you don't get hit by a hurricane in the meantime. Ventilation, poorly ventilated roofs, especially in conjunction with the orientation of the roof, especially those over cathedral ceilings, which are hard to ventilate, will show signs of overheating and may also show signs of moisture damage. So again, buildings are not designed to be completely closed off and tight. You need ventilation underneath. So the best case scenario for a roof is that the condition on the back side of the roof is as similar as possible to the front side of the roof. So you want air moving, typically through soffit vents out through a ridge vent. There's a million different types of ways to ventilate something. We won't go over that too much right this second, but again, that's a huge issue. If there's poor ventilation, you can get overheating, and you'll see that degradation come to the surface pretty quickly. Structural issues, right? Both the roof sheathing and framing can sometimes indicate structural issues revealed by the roof surface. Such problems may be apparent as cracked shingles or tiles above a structural defect. More commonly, there will be a wavy look to the roof caused by thin roof sheathing that's overspan that we talked about a little bit earlier. If your sheathing is overspanned, you're going to see deflection in that sheathing. Is it an actual problem? It may or may not be. It may, a lot of people, when you call out an issue, they might say, well, the house is 50 years old, it hasn't caused a problem yet. And it's like, yet is the operative phrase there. And it may never cause a problem. But if you have an overspan sheathing, it's going to tend to deflect and eventually probably delaminate or something like that. So you can have all kinds of issues like that. Installation defects. All roof systems are only as good as the installer. Like I said before during the break, if you guys didn't hear, it's not uncommon to see all types of failing due to poor fasteners or other installation problems. So the quality of the roofer can maybe even overcome a material that's not as high quality as another material, but the installation's so good. One shingle to the next, there's a lot of differences. There's a lot of differences in quality, and some people say IKO, those are terrible shingles. You got to use a certain teat. And then I've heard people say Owens Corning's terrible, and then other people swear by Owens Corning. So the quality of the roofing material is a bit subjective, to be honest with you, but the quality of the installer is not so objective. Nailing in the, installing fasteners in the proper locations, installing any, I could teach anybody in this room how to install shingles out in the open plane of a roof. Anytime there's a change of direction, anytime there's flashing needed, anytime there's a slope transition, these are all the areas where roofs are made or broken. Made or broken. Usually make or break is an easier thing to say. But the quality of your roof is a lot of times tied to the quality of transition areas. So, as much as I love watching Kenton Shepherd do everything that he does, because he is a true master, we're going to skip the video for now. But as you can see, if you can see through that transparent blue box, he's using that 3-point method. He's grasping the ladder rungs as he goes up. He's got a really appropriate slope on his ladder. He's got it three rungs above the access point. And, he is set up on concrete with some oil stains nearby, but you can see that the feet of his ladder are not set in an oil stain. They're set right in a good open clean spot. It's nice and dry outside, so the rubber feet on the bottom of that are going to grab that concrete really nicely. So that's just ladder safety stuff to pay attention to. Again, if I'm pulling up to this area, it's like, well, isn't one spot just as good as the next? No, not necessarily. There's all kinds of different things you can pick and why you would pick them. One area that I would specifically avoid is that nice red door. It does have a lock on it, like an access key type of thing. So probably nobody's going to come out there, but I would just make a habit of never setting up your ladder in front of a door, especially one that swings out. Roof drainage and gutters. Unless the roof is sloped to drain over the roof's edge, there should be a drainage system installed for the roof. Roof drains could be installed at the low portions of the roof. Roofs should have some type of controlled method for disposing water that collects so it discharges to the ground surface several feet away from the foundation walls or into a drainage system. Gutters are sometimes not installed in areas that don't get heavy snow or much rain. While roof overhangs and porch roofs protect building walls from impinging rain, gutters serve to protect building walls and foundation from roof water runoff. Roof gutters, downspouts, and leaders or diverters from the initial components of a drainage system for the building and site. Form the initial components of a drainage system for the building and site drainage. Proper design for gutters and downspouts for water shedding sloped roof systems should be assessed during a roof inspection. It is something, according to standards of practice with InterNACHI, that you're required to observe and describe the roof drainage system. Common problems with guttering are associated with installation and maintenance. Home inspectors can check if properly sized materials are being used. Huge thing to call out. Almost nobody sizes gutters properly. A 5-inch gutter is pretty rarely an adequate gutter for drainage. You don't necessarily have to call it out, but if it is a big roof and it's very steep, I would call it out. And then the installation of the shingles themselves, like in North Carolina, for instance, for whatever reason, everybody seems to overhang the shingles like 3 inches and they hang into the gutter. That's a defect. That's a problem. Eventually, those shingles will weather in that area where they're being forced to bend. The shingles shown in these images are a lot more in line with what manufacturers recommend, which is no more than 3/4 of an inch overhang. And that allows you to, install a drip edge and bond those shingles at the drip edge, and you're good to go there. So, discharge water at the building's inside corners should be avoided. Some local stormwater codes may require special filtration treatments of roof water runoff. Effective roof drainage is a must for two reasons. First, the roof system needs to drain quickly so that large volumes of water aren't trapped on the surface. And the second is that water runoff from the roof needs to be managed so that it's not being directed toward the foundation. And that's usually one of the bigger issues you'll see. Sometimes even in like lower income areas, and not even necessarily just those areas, but places where it seems like, the you'll just sort of notice indicators that corners were cut wherever possible. And so what you'll see is water running off. And if you look close to the foundation of the house, you'll see all kinds of issues where the water has, displaced. It erodes usually if it's like a grass and dirt or even like a mulch. You'll just see erosion in like this nice little gully right next to the foundation of the house. And that is not preferable for so many reasons. Gutter systems, like everything else, have evolved greatly over the last couple hundred years, starting out as crude wooden troughs, which I've still seen used for charming little houses that look like cottages from storybooks, and ending up with vinyl and metal systems that we use today. It's fair to say that most guttering systems are high maintenance. Homeowners are with conventional uncovered gutters are required to regularly clean out vegetation and debris that get blown into them, and that's not just in the instances where there's trees nearby. If there's airborne seeds and things like that, and the gutter's not cleaned out regularly enough, you'll get debris in there and start growing little trees in there. Roofing gutters may be sloped down towards the downspout, and they should be sloped down towards the downspout at a slope of 1/16 per foot or 1/4 inch per 5 to 10 feet. That's a general rule of thumb. It's not building code. It's just a best practice that may be used by a home inspector when observing a gutter system. The point is that a gutter should be sloped towards the downspout, hopefully in a very inconspicuous way. A very low sloped angle may not allow water to move effectively, and a much greater slope may cause the water to move at too great a speed, potentially resulting in an overflow at the end cap of the corner. So again, you almost shouldn't even notice it unless you're looking at it with a trained eye. And a great way to look at and see is the gutter is typically not wider than the fascia board that it's attached to. So it's usually not taller. So what you can look at is the exposure of the fascia board either underneath the gutter or above the gutter. And you can see, does it look like that exposure shrinks, away from, like, it should grow a little bit towards the downspout. If you're looking above, right, if it's attached real high near the shingles, you're not going to see a whole lot of fascia. And then if it's running down correctly towards the downspout, there should be a little bit of exposure as you go across. But again, if it's installed at a ridiculous angle, that water is just going to be pouring and leaping over that end cap whenever there's a heavy, heavy rain. In terms of standards, home inspectors are not required to measure the amount of gutter slope. So to do it accurately would be time consuming and require a transit or a water level, and that would exceed InterNACHI standards of practice. The point, conversely, is if you are going to do it, make sure that you are using a water level or a transit. Make sure that you aren't just calling something out as not appropriately sloped, because if it, visually doesn't look correct to you, it's better to test it and be right rather than to not test it and be wrong. Because again, if you're calling out a fix, you're saying, hey, this gutter is not appropriately sloped. That could lead to potential issues. Sometimes people say, no big deal. Or sometimes people will say, I want this fixed. If they say I want it fixed and then a contractor comes out and actually measures it and says, this gutter is perfectly appropriate, you're left with egg on your face, so to speak. And typical gutter systems hold up better when the brackets are spiked or screwed through the fascia and into the rafter tails or the ends of the rafters, not just into the 3/4 fascia board. Why don't we look at the various types of gutters and their common weaknesses, as well as their materials, installation, and maintenance. And again, to that last point, you may not be able to tell this by looking from the outside, but if you see a gutter attached to fascia, there are gutter spikes or gutter screws that are usually clipped over the front of the gutter and then slid down on the back of the gutter, and then a screw goes right in. When those are installed, they should be screwed into a rafter tail, because if they're held on by drilling a hole into a wooden piece of fascia, eventually it's possible for that hole to rot out. And if the water's not running out of that quickly enough, it can get very, very heavy, pull those spikes out, and you run into to a bunch of issues. So no gutters, right? Not all homes were designed to have gutters. In some areas of the United States, they're deemed unnecessary due to very low rainfall or heavy snow accumulation. Even in areas with high rainfall, some homes were designed with a long eave overhang, such as, something with a 4 or 5 foot overhang, cantilevered out to direct water away from the foundation. However, it does not always have the desired effect. So, you know, it's not fair to say they're always preferred or you should always have gutters, but I would say definitely more often than not. Yankee gutters are a little more than diverters directing water away from specific areas of the structure, particularly over doorways and entrances. Sometimes they're also installed to protect other areas, such as the eaves. Yankee guttering was the earliest form of water management. On some very old homes, there are still planks held in place by wooden blocks. Normally, they were lined with tar to both protect the gutter and to seal it to the roof. The modern version of Yankee guttering is a metal type that is still seen on new construction directly over entryways, mostly called a rain diverter. Wooden guttering is actually still fairly common. It's still being installed as recently as the 1930s. Originally, it consisted of little more than wooden troughs, but these were later milled out of closed grain timber and are very similar in profile to modern metal and vinyl systems. In many cases, they were lined with either tar or with metal, such as lead, copper, or aluminum. I've actually inspected at least one, maybe more than one, uh, wood trough gutter style with copper nailed inside. It's very, you know, kind of cool looking. Generally speaking, most older systems still in operation have not been well maintained. When they start to rot, any moisture is transferred straight to the fascia, soffit, and rafter tails. So gutters can be a huge help, but they can also be a huge problem if they're not well maintained. Cornice or gully guttering, that's an integral part of the roof system. Typically, the guttering was laid down with the roof framing and sheathing and then covered with metal or rolled roofing running up under the roof covering. The downspouts are often hidden inside posts and pillars to mask their presence. When these fail or when the downspouts become blocked, they can wreak havoc on the roof structure. Most of these systems have now been built over and normal fascia applied gutter has been installed. Metal and vinyl guttering, those are the two biggest problems with steel guttering are rust, if not properly maintained, and the potential for leaks in joints and downspout connections. Steel guttering comes in shorter lengths, so there tends to be many joints in the system and not just at the corner because it's not an unlimited length. Aluminum guttering is quite often formed on site. I've installed gutters, I've run these machines. There's a giant coil of metal. There's a profile inside the machine, and as you run through, you'll either use a coil for 6 inch or a coil for 5 inch. And as it runs through the machine, it gets profiled into that normal, usually a K style gutter, but you can get other ones. But essentially, the only thing that's limiting you is the amount that the roll has on it. So you can get a 100-foot run of gutter out of something like that. I oversaw a project last year or 2 years ago that used like an 88 run of gutter. It's It has fewer joints, but those at the corners and downspout connections should still be fully evaluated because when you connect those corners, it's difficult to do it properly. You should use a bead of sealant, should be pressed together. Again, not just like zip screwed a bunch of times together. The most common method of connecting the components is using aluminum pop rivets. These frequently fail either from impact damage or building movement. Copper guttering in your area may be a lost art. It's not in ours. We've got copper gutters down here. It may appear on high-end new construction and on quality restorations of older properties. What makes copper systems desirable is that all of the joints are soldered, including those of the downspouts. That tends to make for a system with a very long service life. Vinyl guttering is not only very common in new construction, but is also the do-it-yourselfer's material of choice. It's the available off-the-shelf at most home improvement stores. Prefabricated angles, corners, and connections are readily available, and installation requires no special tools or even much technical aptitude. The inspection image shows a vinyl gutter system on the lower left. Usually, a quick way to recognize it is usually a bit more squared off. Those square vinyl gutters coming down the building. The gutters used on aluminum are going to have either a 3 or a 4 inch widest face. So you'll have a 2x3 or a 3x4, and it's rectangular. Whereas these ones are sort of squared off and they're a bit blocky at the joints. So you can kind of hopefully identify that quickly. And if you do, that's what I was talking about earlier when you're setting your ladder up. Be very careful. That's a very flexible gutter until it's not. So, like most plastics, it's a bit flexible, and then you'll have a permanent deformation or a crack. So just be very careful when setting your ladder up on vinyl gutters or really any gutters. Thicker gutters usually are the ones that are seamless. Again, they're not impervious to being crushed, but definitely if you see seams in the gutter, be very, very wary of where you're setting your ladder up and whether or not you're using standoffs like we talked about before. Regardless of the material or style, all gutters tend to exhibit common problems and should be inspected primarily the same way. The inspection image shown shows a common defect of a disconnected downspout. So again, in that middle bottom picture, you can see that, for one reason or another, that downspout was disconnected, and that renders that largely ineffective. I would say 60% ineffective in this instance. But kind of like anything else, you want to standardize your approach as much as possible. So you don't want to have a vastly different inspection approach to a copper gutter system than you would from a vinyl gutter system or an aluminum gutter system. If it's a gutter, check to see if there's any joints, check if those joints seem to be functioning properly, check to see if there's anything sagging or disconnected. Check those corners and downspout terminations. There should be sort of in your head a normal flow, and similar to in engineering for structural assessments, there's a load path consideration, or for wind loads and things like that. Similarly, there should be sort of like a water path consideration in your mind, like where is water going to go and what's it going to do? And if you see that there's a long run of gutters and it's recently rained and there's a bunch of water just sitting in the middle of the gutter, or much worse, if you see the entire gutter is full of water, it's a clogged downspout. Again, these are things that you're normally just going to check for. When you check a gutter system, it shouldn't super matter which type of system it is. Again, if it's a copper gutter system and there seems to be a soldered joint, if it's a brand new gutter system, I would assess it at the solder joints to see if anything got burned, because that can actually weaken the material rather than strengthening it. But again, there's a few small considerations that would separate one gutter system from the next, but generally speaking, you want to use the same approach, especially for reporting. You want to have a template, right? So you want to have the same few defects that you're normally going to call out. If something's disconnected, that's a problem. If something seems to be broken, that's a problem. If it's a galvanized or a steel gutter, you might look right up underneath it and see a bunch of rust holes. That's a problem, right? So here's the what to look for list when checking the gutter systems. Again, I'll read it from the notes. We just went over a few. But does the gutter seem to slope towards the downspout? Are there any downspouts present? Does it appear to have an adequate number of downspouts? Is the guttering securely fastened to the building? Are there downspouts present is actually a question that I would ask, because a lot of times when it's a real estate transaction, they're sprucing up the home as much as they can in preparation for a sale. So sometimes that includes giving the siding a paint job. And what some contractors will do is pull those downspouts off, set them in the garage somewhere with the intent to put them back on later. And sometimes it just never gets revisited. So house gets this fancy new paint job with a bunch of gutters that just have holes in the bottom at the corners where the water's just going to pour out. So again, if it were me and I saw a house with no downspouts, I would check the garage and see if either inside or behind the garage, if there's a pile of downspouts just waiting to be reinstalled. Are gutter spikes backing out? Are brackets missing? Can you see signs of leaking at the joints? Are there any missing gutters? That happens a lot. Sometimes an overweighted gutter will fall off the house, or wind might damage a gutter. Do you see any damaged gutters? Are the gutters blocked by debris or even rooted vegetation? Take a good look at the bottom of the gutters. Like we said, those steel gutters can wear into holes. The contents will typically point to the problem with the roof covering, to problems with the roof covering. For example, if there's a large amount of shingle aggregate in the gutter, that could be a sign that the roof covering is nearing the end of its service life. Be careful. Brand new installations can also result in some aggregate in the gutter. They call those hitchhiker granules. When a brand new shingle is put on a roof, it's got a bunch of loose granules on the surface that are just going to kind of like wash off pretty soon. So if you can't really tell the difference between a new and an old roof, don't rely on aggregate in the gutter to tell you that, because aggregate in the gutter could mean a roof is very new or it could mean a roof is very old. The bottom right inspection image shows a lot of granule material inside the gutter that indicates the age of the roof and the condition of the roof, roof covering material. So again, you can see it now. Again, there's a lot of aggregate in there. It's a little bit grayed out, so it seems like it's been there for a while, but looking at the shingle in that exact same image, it doesn't look like there's a tremendous amount of granule loss. It's a very low resolution image, so I can't tell you for sure whether or not I think that's how old I think that roof is, but it's not a super old roof. There is a lot of aggregate in there. And even small hailstorms, if they don't cause significant catastrophic hail strikes, they can actually loosen up a lot of granules and you end up with handfuls of granules in the gutter. So take a look at that and see what you see. Downspouts and terminations. There's a very general rule of estimation that every square inch of downspout is capable of discharging drainage for 100 square feet of roof surface. So a 2x3 downspout can handle 600 square feet of roof, and a 3x4 downspout can handle 1,200 square feet of roof. And in some instances, somebody might call out a 5-inch gutter as inadequate in terms of drainage because the roof gets poured over so the water pours over the edge of the gutter every time there's a heavy rain. That could mean that the gutter is undersized, or it could just mean that the downspouts are undersized. So it's very common and very preferable in a lot of cases to see a 5-inch gutter with a 3x4 downspout. Usually it's paired up: 6-inch gutter, 3x4 downspout; 5-inch gutter, 2x3 downspout. But you can up the drainage of your gutter system just by attaching a larger downspout. Because why the water might be pouring over the side is that the downspouts are just being overloaded and they're not able to drain fast enough, especially if you're washing out debris in the gutter at the same time it's trying to drain water. So if there's a tremendous amount of water coming into the gutter, it's rushing down to the downspout. Well, if it's washing a bunch of aggregate, maybe leaves and other things, those may not clog the downspout, so to speak, but they could slow down the water flow enough that it starts to pour over. And then people are questioning whether or not they have good gutters, whether or not they have adequate gutters, and the like, where it'd be a lot cheaper just to upgrade all your downspouts. And to be honest with you, you could upgrade all your downspouts to 3x4, and if it still keeps happening, you can pull those downspouts off and then replace the gutter and still use the same 3x4 downspouts. Just a thought. So for a 30x50 house with a gable roof at a 412 slope, a quick method to calculate the square footage of the roof covering is 1,500 square feet is the footprint by 1.054, which is a slope multiplier, which results in 1,581 square feet or 15.81 squares. This assumes a simple gable with no hips, valleys, dormers, or overhangs. If there's a typical eave and rake overhang, say 12 to 18 inches, you'd add roughly 10 to 15% more material, bringing you to around 17.5 to 18.5 squares of actual roofing material. So if a common 2x3 downspout can manage 600 square feet using our general rule, then we need at least 3 downspouts to serve our previous roof example. So again, if you want to use those rules of thumb, those would be great things. So if you're going to call something out, you just always want to explain yourself as to why you're doing it. Now, you are an expert. If you want to put something in your report and don't say why you're putting it there, just say, hey, take my word for it. Again, you may be in a battle with a contractor on the back end, so it'd be really good on the front end to say, hey, I think this is an inadequate drainage system, and here's why I think that. Because, and you can write down this exact verbatim quote, a general rule of thumb is, fill in the blank, so the size of this roof approximately would necessitate 3 downspouts on the front to handle the water typically draining off that front slope. There's only 2 downspouts, yada, yada, yada. You guys are inspectors. You get it. You want to add your verbiage in, but I like to use my inspection report as an educational tool. So if there's an opportunity for someone to understand why I'm seeing something or saying something, I'm going to put it in there. I'm not educating a competitor down the street or something. I'm going to educate my client because I want them to understand what I'm seeing and why I'm seeing it. If I say something's a problem, I want them to be able to agree with me and not just like shout from the rooftops that there's a problem. I want them to understand what the problem is, why it's a problem, and how big of a problem it is. Most downspouts are made of the same material as the gutter system, so they tend to suffer from similar problems but with a few twists, especially in the area of mechanical damage from proximity to high traffic areas. So here's what you want to inspect the downspouts for. Look at the connection between the downspout and the gutter, because that can be an issue sometimes. There's supposed to be a grommet that comes through the gutter and sits into the downspout. And a lot of times, if you know the gutter, a lot of times what I see is the gutter gets over tightened, and so when it's supposed to sit flat on the bottom, it's sitting back. And so someone tries to overcompensate for that, and they don't seat the grommet in the downspout correctly. And again, that may not ever be a problem because as long as it's in there to a certain degree, all that water is going to rush through there. It may just be unsightly. Again, everything depends. The home, sorry, leakage in joints because sometimes they'll have been installed upside down. So what you should see is for every section of downspout coming down, the top part should go inside of the bottom part. Did I say that correctly? Yes. The part coming down into the next section should fit inside. That way there's no water hitting a joint. If somebody put the bottom part inside of the top part, there's a whole ring around the outside edge that's probably going to leak whenever there's a rain, which may or may not be a problem. Could be a problem if they use the wrong fasteners and they're corrosive. You guys fill in the blank. Look for impact damage from car doors or etc. Some people, especially on like a lot of cookie cutter houses in Charlotte, you'll have a gable roof with a front and back slope, and you'll have an intersecting gable left to right. That's typically the garage. To the left side of that, people put their trash barrels, and there's always a downspout right there. And it just inevitably gets hit and banged and all these things. Look for downspouts that terminate onto another roof surface, as that will quickly erode the roof covering material at the termination. And look for whether the termination is directing water away from the foundation. And you can see where it shows that downspout extension being too short, that water is not being directed away from the foundation. It's allowing water right in where that water flow is probably going to start seeping in to that intravenous soil, or sorry, impervious soil. So the soil near the home is permeable, and then you have like a clay soil nearby that. So if you have a downspout spitting out too close to the home, you could have a situation where it's almost catching it like a bowl, and then it's going to end up causing hydrostatic pressure at the foundation wall and pushing water in. The home should not have a gutter system that is directing roof water runoff straight down into the foundation. If the downspout discharges or terminates too close to the foundation, recommend the downspout diverter extension be installed. In that inspection image we were just talking about, obviously that water is being discharged to the corner of a concrete foundation, and that is a defect. Local building practices may include that the termination of the downspout be a minimum of 5 feet from the foundation due to soil conditions. That inspection image above is of a gutter leaf guard. So that one with the guy's hand in it, that's a leaf guard. So again, if you have a bunch of trees nearby, you're in for some trouble. It can just be, they've tried every which way to create gutter screens or gutter guards or, all these different things. And so there are surface tension gutter guards like the gutter helmet or leaf guard that's like $80 a linear foot. And it's like, I want the best of the best. So somebody will have a high-end home and they say, I want the best gutter guard that money can buy, meaning the most expensive. So they think, I'm going to spend the most money I can. Well, then they have a surface tension gutter guard with a steep slope roof, and it's not shown here, but it, kind of functions like a helmet. Maybe you guys have seen it. It's more appropriate for a lower slope roof where the water kind of trickles over the edge and then falls into the gutter. Well, it's called a surface tension gutter guard. And if it's a steep slope roof, it's just going to hit the gutter guard and start spraying over. So your gutters will never have leaves in them, but they might never have water in them either. Underground systems. While you cannot be expected to evaluate underground systems, it's worthwhile to have some basic knowledge of the systems and to understand the potential problems. Underground terminations usually connect to one of 3 system types. On-site drainage, this is where the gutters connect to subterranean piping that simply takes the runoff to a lower area on the property and discharges it right into the ground, well away from the foundation, and sometimes they incorporate some kind of a French drain system. Connection to foundation drains. The downspouts in these systems are connected via vertical drains to the home's foundation. or drain tile system. This may ultimately be connected to the municipal storm drain system. And then French drains and dry wells, those are pits or channels dug and lined with a membrane and normally filled with crushed stone. This leaves a lot of airspace in the dry well. When heavy rain is directed into the drain system, it's able to hold a large volume of water until it's able to percolate into the surrounding soil. Those systems are most common as a retrofit to alleviate known rainwater problems, and they can be very effective. All underground drain piping can suffer from failures, and while the inspector should disclaim these in his report, it's good to know what the potential problems are. The most common issues are pipe silting up due to poor separation from soils, blockages from leaves and other debris getting into the system, root systems from trees and shrubs infiltrating and choking off the pipes, and pipes collapse from vehicles driving over the ground above them. So, just some things to keep in mind. Internal drainage. So, many flat roofs have internal drainage systems, although they're not common in modern residential construction. They will be found in older homes and many commercial roofs. The drainage system relies on the roof having one or more low points to which the water runoff is directed, where it will then run down into internal piping connected to the drainage system. So that's a tar and gravel roof, it looks like, on that residential home. A lot of instances, what they use is tapered foam insulation board that is under the roofing material. So the roofing material is applied over top of that foam board, and because of the tapered foam boards, they run into scuppers or in, field drains. So check for poor flashing between the roof covering and the drain, right? Check the drains for blockages due to leaves, which is super common on a flat roof, especially smoother flat roofs. So if you have a tar and gravel flat roof, there's a lot of surface aggregate. In a lot of instances like that, where there's surface aggregate, typically those do end up getting sloped a little bit and pitched towards an edge drainage system. For obvious reasons, a lot of the aggregate's going to just get washed out into the drain if you install a field drain inside the perimeter of an aggregate roofing system. Verify the roof has an adequate slope, which should be a minimum of 1/4 inch per foot, like we mentioned earlier. And the internal pipe system could technically fail due to corrosion, especially older systems are going to utilize maybe a cast iron piping system, and then those can rust out and fail. And the failure of a building's main foundation drainage system could impact proper drain flow, which again doesn't necessarily totally impede the flow and stop it up to where it's just going to end up with standing water on the roof, but it might slow it down, in which case high volumes of water may get stopped up. So, like we said, the common problems with that system are inadequate slope, poor flashing, drain blockage, failure of the internal pipe system, or failure of the main foundation system, foundation drainage system. Significant structural problems can be caused both by water getting in under the roof coverings and from systems that have not been draining properly. Snow can also overload the roof structure and contribute to such problems. These systems should have leaf guards installed at the drains to prevent blockage, and they should always be monitored. And if you're inspecting a flat roof where you see a drain and there's no drain cover on it, I would definitely call that out, just the same as I would call out a missing downspout or anything else. We're not an hour already, are we?
We're a few minutes out.
Yeah. You want to take
Let's
a
go ahead
break?
and take a break. Yeah.
Yeah, let's do it.
All right, guys, we'll break here for the next 10 minutes. And in the meantime, let's answer some questions. Looks like, let's see. Christopher says, thank you. I also commonly see mixed attic ventilation methods like gable vents combined with box vents or ridge vents, but I rarely see any visible ramifications from it. Matt, how often do you actually see real world issues caused by mixed ventilation? And when there's no staining, moisture problems, or shingle deterioration, how do you approach reporting it?
So mixed ventilation is not always a call out issue unless you can identify those vents in the attic space. Because a lot of times, if there's a vent that somebody doesn't want to be active, like so for instance, probably the biggest mixed ventilation problem I would think of is a power vent in conjunction with a ridge vent, because a ridge vent is a passive ventilation system, whereas a power vent is an active ventilation system. So normally a ridge vent would act in conjunction with soffit vents, where the soffit takes air in. As that hot air rises, it moves through the attic space and gets pulled out into the less dense air outside of that ridge vent. And so if you have a power vent right nearby, if the power vent is trying to pull in outside air, well, it's probably going to pull in the outside air that's leaving the ridge vent, and then that air is going to rise and come out the ridge vent, and you're just going to kind of cycle the ventilation in that top 2 or 3 feet close to the ridge. That would be probably your most common problem, but I would be careful calling it out because a lot of times people will leave an attic fan there because they don't want roofing contractors, their crews a lot of times charge for any additional like weird things they ask them to do. So if you're in a residential area, let's say in a city or something like that, they just want to bang roofs out. And so if you run into a an attic fan situation, they'll say to the homeowner, "Hey, is that active?" Homeowner says, "I don't know," or "I don't care." They'll oftentimes say, "Hey, look, in order to have like say a GAF warranty, you have to use four of their components. One of those being a ridge vent, which is one of the easiest components to have to be part of that system to get a warranty or something like that." And so a lot of times, but they say, "Well, don't close the thing off because I don't want you having to do any kind of additional repair to the decking because that's going to come with additional money. So leave the attic fan in place, but also use the ridge vent." So that's a combination situation, but it's not really. It looks like one because you can see two different types of vents, but one of them's inactive and one of them is still being used. So I would say I don't often see real world issues caused by mixed ventilation. If it's actually mixed ventilation, there can be a problem, but most times it's not. And when there's no staining, moisture problems, or shingle deterioration, how do you approach reporting it? I wouldn't. I personally don't really speak to mixed ventilation very often. If I see ridge vent and I see soffit vents, I assume that that's an active thing. But again, if I'm in hot weather, just keep in mind, just because an attic fan is not running doesn't mean it doesn't work. They have thermostats attached to them. And so when you have it activates, say, above 130 degrees in the attic. And so you might be up there in a normal weather situation. You see that fan, it's not running. Maybe it's active, maybe it's not. But if you're on a hot roof and you see a ridge vent and the attic fans are all running like crazy, I would probably call that out because there really isn't much benefit. You'll have great ventilation, but what you might actually see is degradation of the shingles below the attic fans, and then the ones near the ridge just look prim and proper. So I'll give you another it depends. But most often, I would say mixed ventilation is not something I'm going to make a point to call out in a report unless I can certainly confirm that it is mixed ventilation. And then I'm not going to call it out as some material defect. I'm just going to say, "Hey, this isn't preferable. I would probably just unplug that attic fan and call it a day."
And at the eaves, can floor grills, soffit vents supply adequate cross ventilation at 6 to 8 feet separation at a two-story roofing system?
Oh, meaning not having a perforated soffit, but just having little vents. Um, it depends. No, I mean, certainly not something I'm going to get into like splitting hairs over whether or not the grills are close enough. I would say 6 to 8 feet. Sure, I don't see any problem with that. I could be proven wrong, but I certainly wouldn't call out. I wouldn't measure the distance between two grills and say they're too far apart. If they have any ventilation at all, I would call it a good thing. And to be honest with you, probably 90% of the roofs you're ever going to look at don't follow the actual rules of what adequate ventilation would be. I would say if you've ever been on a roof, it probably didn't have adequate ventilation.
How would you address heavy moss growth on the roof?
I would tell them that can be a problem because moss and other organic growths, especially lichen. Lichen's probably a lot worse than moss is, but either way, lichen happens to be very basic on the acid scale, and it tends to degrade the bitumen in the shingles, and it kind of digs roots down in there. And if something changes and the sunlight comes and kills it, it'll fall off the roof and it'll take some asphalt and some of the surface aggregate with it. So I would call it out as, in need of some kind of maintenance. Again, this is one of those things that is it's just a suboptimal situation. If you have a tree blocking the sunlight from a roof, you're probably going to get organic growth, especially the further north you go because there's less heat kind of killing that organic growth. So if you have a bunch of moss buildup on a roof, I would definitely call it out as a potential issue. But the fix for that issue is probably going to be cutting trees down, not necessarily like washing it off of a roof, because washing it can have really harmful chemicals. And even if it doesn't hurt the roof, where do those chemicals go? Well, if there's a roof drainage system, it carries it into the surrounding area, and then all of a sudden you have a bunch of dead grass in the backyard. So there's not a great fix for it. I would call it out just as a maintenance issue, but I wouldn't necessarily write home about it and try to prescribe some kind of a fancy fix for it.
Should drywall screws installed at a gutter system be called a maintenance or a repair defect?
Depends on the terminology you're using in your report. I would say I would definitely call it some kind of a defect because those screws are corrosive and they're eventually going to fail. So they will rust, they will fail. It's not if, it's when. They're going to fail. So you need to have the appropriate screws for a gutter. There'd be self-tapping screws with hex heads. If I see anything other than that, depending on the roof system, obviously, or depending on the gutter system, obviously, it, if it's not a hex head self-tapping screw, but it's a copper gutter system, then copper gutter systems are going to have copper fasteners and rivets. So, but yeah, a drywall screw is something I would certainly call out because eventually that's going to fail. The impact of which is unknown.
What's the recommended downspout replacement or placement, not replacement, placement?
What is the recommended downspout placement? There's not really one other than to say try to get it out of the way of everything else. I don't know exactly what the rule of thumb is, but on extremely long runs of gutter, they actually it's difficult to achieve that quarter inch every 10 feet or so because if it's a 100-foot run of gutter, right, 10 times a quarter inch, that's a couple inches by the time you get to the end, and you might not have that much space on the fascia board to do that. So if it's a very long run of gutter, one on each end and one in the middle. If it's a shorter run of gutter, hopefully you just have one downspout, and it's probably, it definitely at the end is the first answer. Like you want it at the end of a system so that everything can kind of easily pitch towards it and run out of it. But, recommended placement, I would say on the corners and places where they're sort of out of the way and they're not like, you get this big, beautiful siding job and there's a gutter, a downspout running right down the middle of the house, not so fun. So ask an interior designer what they think the right placement would be. I would say functionally, as long as it's in a spot where you can have things run down to it. And if you don't have enough, if it's too long of a run to only have one downspout, then you would have it a little bit higher in the middle, run that quarter inch per 10 feet out to either side, and have downspouts at either side.
Right. He also made the comment, the downspout discharge onto the roof line is considered a defect in the 2025 IRC. Got any
And
comment to that?
yeah, I would say just be obviously, I'm sure you guys all know we don't do code inspections, so be very careful using the IRC. Like I would never reference the IRC unless you're going to use it for your whole inspection. So we don't say code, we don't say IRC. It is not up to code if it discharges out onto the roof. But again, if you're going to tell them that, then you should prescribe a fix and tell them what a better way to achieve the proper drainage would be. And again, depending on what it is, the IRC is for new construction and re-roofing. It's not for like repairs and things like that. So the international existing building code is also an appropriate thing when you're talking about if somebody's repairing a roof or if it's causing some damage, what can you do? Again, it gets very complicated when you start involving code. So yes, I agree. The IRC does not dictate that that's the way to do it. It would say specifically that's the way not to do it. But I would be very careful, as always, just use terms like best building practice and stuff like that.
It sounds like the primary way to distinguish between an aluminum and steel gutter is the length of it. Is steel even used much?
It's not used a whole lot. The length of it, yes, but aluminum gutters, you can buy them at Home Depot in 10-foot lengths as well. So, just because it has seams in it doesn't mean it's steel. But you can tell Yeah, I with roofing and with gutters, you can use a magnet test. You can just usually the same material is going to be used for the gutter as the downspout. So you take a little magnet, see if it sticks to the downspout. If it doesn't, it's aluminum. If it does, it's steel. And another way to tell steel is the rust holes in the bottom that are inevitable when you use it. So yeah, aluminum is by far the most common gutter material.
Insurance companies are having a real problem in New York with moss. Oh, okay. Yeah.
Insurance companies are having problems all over, but they end up being the house and winning eventually. So don't you worry about the insurance companies.
Let's see here. Are there any situations where you call out a roof as having inadequate ventilation? If so, what are those configurations without doing some kind of calculation?
The last sentence is the most operative thing. There's a calculation. It's like every 25 square feet of attic space needs to have 4 feet of ventilation. It's some, I don't know the calculation offhand. The answer is I would absolutely never call out inadequate ventilation unless I'm willing to do the calculation. So, what does that mean? I never call out inadequate ventilation because pretty much every roof, I've been on 10,000 roofs. I haven't seen a whole lot of roofs in that 10,000 that were adequately ventilated. And again, if somebody says, well, this looks like it's fine, or this looks like it's not fine, that's not an answer. You can't tell me it doesn't look like it's adequately ventilated. Do a calculation and tell me whether it is or isn't. And if you're not going to do a calculation, don't talk about it.
All right. Last question. Where do you draw the line between cosmetic hail damage and functional hail damage? I've inspected roofs with very minor marks that insurance approved for full replacement, and others with far more significant impact marks that were denied. Since insurance decisions vary so widely, how do you, Matt, describe hail impacts in your reports in a way that informs the clients but doesn't overstep into insurance determinations while still protecting yourself as an inspector? It's a good question.
I happen to be Hague certified. I happen to be a certified master trainer through the National Engineering Institute. I train all kinds of people specifically in hail damage to roofing systems. So the one answer I would have is call me sometime and we can have a very long discussion about this because the reality is insurance companies policy verbiage typically dictates that hail damage is covered, and then they proceed to define what they mean by hail damage outside of the insurance policy by internal guidelines. Then, when these things go to court, very typically, hail damage is defined as any demonstrable detrimental effect had on a material. That's a much wider scope. And so that definition could be used in the context of an insurance policy, but then you have to wonder who it is that's making the determination about it's a hugely wide scope of definition. And so who's defining it really, that is what the criteria depends on who's defining it. So if an insurance adjuster is defining it, he's not actually making the definition. He's telling you what his internal guidelines are for whether or not he can approve something as hail damage. That doesn't really get into the fact that there are cosmetic exclusions. Those would only apply to metal. It wouldn't necessarily apply to asphalt composition shingles. Asphalt composition shingles, Hague Engineering defines hail damage or any damage as a diminution in the water shedding capability or in the long-term service life of a material. Does granule loss or granule displacement qualify as a reduction in the long-term service life? Again, these things are very widely debated by very high-paid individuals, and they still have not come up with an adequate answer. So the real answer to your question is, how do I describe it? I have guidelines that I explain pretty explicitly as to why I call something hail or why I don't. Cosmetic hail damage is not really a real thing unless you're talking about metal. Cosmetic hail damage to an asphalt composition shingle, it just really isn't a thing. So you can make up kind of whatever your internal guideline is for your company as an inspector and just explain this is what I look for when I say this. And that basically eliminates someone from disagreeing with you because if you use your own, like for instance, just say, and I won't take too much time on this, sorry, AJ, but I would say if you want to define hail damage as any demonstrable detrimental effect had on a material that cannot be proven otherwise, well, I would recommend that you at least subscribe to a hail software, which again are hugely unreliable, just for the record. But I would at least have some corollary to say, hey, I think there was a hailstorm on such and such a date. And I define hail damage as fill in the blank. This meets the criteria that Cornerstone Inspection Services utilizes to determine whether or not something meets the criteria for hail damage. And then I would say right in the report, bear in mind, this is a widely debated topic all throughout the insurance restoration industry. So this is in no way a guarantee that the damage identified on your roof by so-and-so inspector would be categorized by your insurance company as hail damage, because definitions inside of the insurance restoration industry vary so widely. So again, this is a conversation I've had for 15 years. I mean, hundreds of hours I've spent talking about this with people and helping them define things. So again, if you're a homeowner or a contractor and you're looking to define hail damage as defined in your policy, you will not find explicit verbiage in your insurance policy giving you a guideline on how to know that. And so who decides what hail damage is in many instances depends on who's paying for it. And again, if it's your mom's house and she doesn't have an insurance policy and you're telling her whether or not she should replace her roof based on what you're seeing, that might be a very different answer than a contractor telling you whether or not your insurance company will be willing to pay. So there's a practical answer, there's a theoretical answer, and I literally did an entire webinar on this very topic. And I've, like I said, done hundreds of hours of report writing and different conversations, one way or the other. So, you can use more vague terms like effect or condition rather than using the word damage. That would be my first recommendation, unless you're willing to do what I have done and include a very robust portion of the report dedicated to, if I think that it's hail damage, I will let my client know, hey, I think there's hail damage. Do you want me? I'm a roof expert. So who would I tell them to call? Would be a roof expert, but I'm also assuming extra liability as that roof expert in saying that I know what I'm looking at and this is what it is, especially when my opinion may vary from the insurance adjuster that the insurance company sends out, who's utilizing a definition that's been written by the insurance company that he's hired by. So that is a very long answer, and I'm sorry, but it could have been 8 hours longer, just to be honest with you. So many roof problems are caused by issues with the framing and sheathing. And in this section, we'll focus on the defects that may be viewed from the exterior of the property. This is one of those cases where standing back and taking a good hard look is better than getting up close and personal, because you want to kind of look for patterns and notice anomalies in those patterns. So ridge issues is one of the more common things to see, especially on older homes. This is what's generally called a saddle or a sway back. This happens when the ridge beam settles down inward towards the center of the roof. There are several potential causes for this. Among them might be a rotten or broken ridge beam itself, an overloaded roof surface, undersized framing members, and maybe a lack of collar ties. A noticeable bump in the ridge can also indicate a more serious problem affecting the whole home structure, such as a footing or a foundation problem. So here's an instructional paragraph for your roof inspection course. Understand rafter tie failures. Take a look at the illustration about a sagging roof ridge. Excuse me. When you inspect a roof framing system, one of the most critical structural elements to evaluate is the presence and condition of rafter ties, or collar ties, some people call them. This diagram illustrates what happens when the rafter ties are inadequate or are missing entirely. The roof load, which includes the weight of the roofing materials, sheathing, snow, and the rafters themselves, pushes down on the ridge board. Without properly installed rafter ties connecting to the opposing rafters at their lower ends, this downward force creates an outward thrust at the wall plates. Think of it like opening a book and pressing down on the spine. The cover naturally wants to spread apart. In a roof system, this outward thrust causes the exterior walls to lean towards and to lean outward and the ridge to sag downward, creating the characteristic humped or sagging roof line you've recognized in the field. During your inspections, look for visual clues like sagging ridge lines, bowed or bulging exterior walls, and cracks in interior finishes near the ceiling to wall junction. Rafter ties are required to resist the outward thrust of rafters. They must be installed at specific intervals based on the rafter span. When you identify missing or inadequate rafter ties, recommend evaluation by a qualified structural engineer or contractor, as this defect can lead to progressive structural failure if left unaddressed. Rafter issues, similar to ridge sag, rafters may also be pushed down towards the center. Wherever possible, try to get a view along the plane of the roof. There can be many reasons for rafters bowing, but here's a list of possibilities: undersized rafters, roof loads that are too high, a lack of purlins or knee walls, poorly modified ceiling joists, and improperly modified roof trusses. Those aren't the only ones, but those are kind of the primary ones. Sheathing issues can be a problem. Originally, roof sheathing was made from 3/4 inch to 1 inch planking, but in the 1950s and 60s, it became common to use plywood or particle board in the 4x8 roof sheets laid perpendicular to the roof rafters. It's not uncommon for the roof to have a wavy appearance, especially, like we said, if the rafter spacing is too much for the span rating of that sheathing. So rafters or trusses that are set too far apart is a problem. Sheathing that's too thin is a problem. Again, those being in conjunction with one another, like typical 7/16 plywood isn't undersized for roof applications unless the span rating is exceeded. Moisture damage sheathing, right? If you have a leak problem, that can propagate throughout a very porous material like sheathing, and then you'll have this big sag that's there, which again, if you see that, be very, very, very careful because that's not going to support your weight. Sheathing that's fitted too closely together and or sheathing that's missing H-clips, which a lot of times you don't necessarily, H-clips aren't required, but they're very useful for creating a small gap. Kind of like if you've ever installed decks or if you know about inspecting decks, the boards that are natural wood are not butted right up against each other because during thermal cycles of expansion and contraction, those things will press up against each other and buckle. And that's the same for sheathing on a roof. And if you see a buckle in a roof that's coming up, if you put your foot on it and it's very hard, that's probably what you're looking at. The decking was installed butted right up against each other, and during these thermal cycles, they pushed against each other and had nowhere to go but up. When inspecting the roof structure from the exterior, the inspector should also pay close attention to the wall structures. If the roof system shows signs of the problems listed above, you may also possibly observe signs of the walls bowing out or the soffits pulling away from the tops of the walls. This is a condition called rafter spread, where the weight of the roof has pushed the rafters outward, resulting in a separation of the roof structure from the walls and pushing the top of the walls outward. The inspection image shows rafter spread in the bowing of a concrete block wall near a tree. So you can see that lower right image is rafter spread, and it's actually pulling that wall outward at the top. And then in the lower left image, that's a very, very common thing that you'll see. People re-roof, they don't, and plywood has a lifespan as well. Just for the record, it's just because it's covered by the roofing material doesn't mean it's a forever material. It's a maintenance material. You're supposed to replace it every time you do a roof 3 or 4 times. A lot of times people don't, and it starts to delaminate. It gets weaker. And it starts to deflect. The dips that significant in the sheathing have got to be a moisture problem or an overspan rafter problem. In this instance, it looks like those rafters are spanned probably about 24 inches from one another. So you probably got thinner plywood, spanned too far. You're going to have dips in that sheathing, no matter what kind of roofing material you put on there. When you encounter a home with a vaulted or cathedral ceiling, you'll often find structural ridge beam instead of the conventional rafter tie configuration. The diagram shows how a structural ridge works as an engineered alternative to rafter ties. In that system, the ridge isn't simple board where rafters meet. It's a substantial beam, usually made like an LVL, a laminated beam, or glued laminated timber, designed to carry the full roof load without relying on rafter ties to resist that outward thrust. And you can see that, when you use a ridge beam, there's going to be a support post on either side. And so that, again, if you don't think in terms of load path, do some study on that and try to think about that. Try to think about where things want to go if gravity's pulling down on something very heavy, where is that load going? So again, on the left diagram, you can see that load is coming down. And so they'll put a bird's mouth cut in the end of the rafter, and it's transferring the load to the walls down to the foundation. And then in the structural ridge, everything is supported on that ridge, which is then supported by the support posts. So again, that force going downward gets transferred to the support post, and again, down to the foundation. So that is how load path works. And so I would encourage you, if you're thinking about why might something deflect, again, look at the type of construction and think about what would happen if this was overloaded. What would happen if I parked a plane on top of the roof? What would the failure mode be? Where would the failure be? The house doesn't just implode. I mean, it can, especially if you have that downward force and then it pushes the walls out, the roof would fall in. That's what's trying to happen in that inspection image shown. So the structural ridge transfers the roof load downward through support posts or bearing walls directly to the foundation, eliminating the need for ceiling joists or rafter ties that would obstruct the open ceiling space below. When a structural ridge beam is used, it must be designed to support the vertical load of the roof, and adequate support must be provided at the ridge beam bearings. During your inspections, verify that the support posts are present at the ends of the ridge beam and at intermediate posts as needed, and look for any signs of settlement, sagging, or inadequate bearing. If you observe a vaulted ceiling area with a sagging ridge or spreading walls, it may indicate that the ridge beam is undersized, improperly supported, or that the system was built with a conventional ridge board when a structural ridge was required. Any concerns about structural adequacy should prompt a recommendation for evaluation by a structural engineer. I hope that goes without saying, but again, I would not speak to structural inadequacy. We look for anomalies in patterns, and when we see something that seems out of place, we recommend a qualified professional in whatever field that is. In this case, a structural engineer would be the most appropriate person to determine whether or not the structure was done correctly. Conventional roof framing. Home inspectors should have an understanding of the two main basic roof structure systems: conventional roof framing and roof trusses. You'll be inspecting the roof framing from inside the attic space, but we have an advantage in technology. Let's strip away the roof and wall coverings of a home and identify some of the more common roof framing members. We'll start with a conventionally framed roof in which individual roof framing members are cut and assembled on site. Common rafters. Those rest on the outside walls at the bottom and connect to the ridge at the top. Those are called common rafters, and they're highlighted in the above illustration in yellow. Rafters on opposite sides of the ridge should be installed directly opposite each other in pairs, although if you see that a few don't align, it's not necessarily a defect. Rafters sometimes have to be moved a little to accommodate components of other home systems. The illustration shown shows a rafter moved to accommodate a vent pipe. So you can see in the upper right photo, those two rafters don't line up, but there was a vent coming out. If you see many rafters that don't align, you may comment on this, but in existing homes, refrain from calling it a defect unless you see indication of major failure. In newer homes, many rafters which don't oppose may indicate poor quality framing. It's an indication that you should look carefully for other problems in the roof framing. So again, if you see a problem with the framing, you could mention it, but if it doesn't seem, depending on how old the home is, if you see framing that doesn't look adequate, but it's not really resulting in any kind of an issue, we're kind of guilty no matter what direction we go, right? Like, you're not calling out issues that people want you to call out. You are calling out issues that people don't want you to call out. You got to cover yourself. Make sure you're out to do a good job and actually help people. And, it's always like you're always a deal killer if you're calling things out that require professionals to come out. And again, to Daryl Gonce's point, requesting a structural engineer come out for evaluation. Structural engineers are not coming out to do an evaluation and write a report for probably less than a couple grand at least. So just be aware of that. But this is part of it. Being in this class, being educated in terms of what is a real problem and what's not a real problem. Purlin. So what is a purlin? A purlin is a horizontal structure member that runs perpendicular to the rafters, providing intermediate support along the rafter span to reduce bending stress and prevent sagging. Think of purlins as reinforcement beams that effectively shorten the unsupported length of each rafter, allowing builders to use smaller dimensional lumber or span greater distances than would otherwise be possible. As shown in the illustration, the purlin bears on an interior load-bearing wall and is supported by purlin braces, which are diagonal members that transfer the roof load down to a lower ceiling joist or bearing point. Purlin braces must be installed at a minimum 45-degree angle and spaced no more than 4 feet on center along the purlin. During your inspections, verify that the purlins are properly supported by adequately sized and spaced braces. Check that braces bear firmly against both the purlin and a ceiling joist or other structural members below, and look for signs of crushing, splitting, or deflection at bearing points. Pay particular attention to older homes where purlin braces may have been removed during remodeling projects or where attic storage has damaged or displaced the bracing system. Missing, damaged, or improperly installed purlin braces may lead to rafter sagging, roof deformation, and potential structural failure under snow or wind loads, which again may not be a consideration in your area. So if you're inland North Carolina, for example, snow load is not a tremendous issue, and wind load, you're not in the category where it's important. So again, just it depends. Hip roofs have hip rafters, which are the diagonal ones running from the main ridge. Hip rafters are simply called hips, and they're shown here as brown. Hips rest on an outside corner at the bottom and connect to the ridge at the peak. Rafters which rest on the exterior walls at the bottom and connect to a hip at the top are called hip jacks, shown in the illustration above as purple. Where ridges change direction, an inside corner is called a valley. And the framing member is called a valley rafter, or you could just simply call it a valley, and it's shown here in green. Valleys are also oriented diagonally to the ridge and exterior walls. They usually run parallel to hips. So on a hip roof, if you have a hip rafter, you're probably going to have a valley. And again, if it's an intersecting roof, if it's just an open hip roof, you probably won't have any valleys. Valleys happen when two planes come in intersection with one another and water gets diverted in these areas, and they're very important areas. Rafters which connect to the valley at their bottoms and connect to the ridge at the top are called valley jacks, and they're shown as light blue in the image above. The illustration here on the conventional ridge shows the orange conventional ridge. In homes with conventional ridges, the rafters support the weight of the roof and transmit the roof load down through the walls to the foundation and finally to the soil. The route taken by the weight of the roof through the framing members, which I've said several times today, is called the load path. The purpose of the ridge is to provide an easy method for connecting rafters at the peak of the roof and to provide better nailing at the peak. Older homes may have no ridge at all. That was a pretty common building practice at one point in various parts of North America, and it's not a defect as long as the rafters oppose each other. Engineered lumber used for roof framing has very specific requirements for connections, and discussing them here exceeds the scope of this series. So we're really not going to talk too much about it, but it is an important concept that you may want to grab somewhere else or on another webinar by InterNACHI. The manufacturers of metal connectors for engineered lumber publish connection specifications in their catalogs and on their websites. So, a general rule of thumb is if you see any modification made to those things, definitely call that out. The illustration shows common rafter top and seat cut defects in conventional roof framing. At the bottom of the illustration, the two seat cuts of rafters are shown. The rafter cut is often referred to as a bird's mouth. You may have heard me say that earlier. It's a special type of cut in the bottom of a roof rafter board. It allows the rafter to sit fully and flatly and securely on the top plate of the exterior wood-framed wall, ensuring the stability of the roof structure. Essentially, it's like a little notch or a mouth that helps the rafter to just have a better grip on the wall support. Because as you can imagine, you've got something diagonal running down into something flat, so the bird's mouth cut gives the rafter a flat place to land on top of the wall. On the left, the bad seat cut is not resting fully on the plate. That may be caused by an incorrect angle of the rafter cut or the slope or angle in which the rafter set is incorrect. This condition does not allow the rafter to rest fully on the wall top plate, which can lead to reduced load distribution and a weakened structure. The good seat cut on the right is deep and fits well over the wall's top plate. So you'd almost prefer one that's too deep than one that's not deep enough or it's uneven or not an appropriate cut for the slope of the roof. At the top of the illustration, the two top cuts of the rafter boards at the point where the rafters meet the top plate of the wood-framed exterior wall are displayed. On the left, the bad cut is not cut properly at an incorrect angle and is not seated fully on the ridge. That suggests poor craftsmanship, which can lead to structural instability and an improper fit at the ridge of the roof. On the right, the good top cut is straight and clean, rests fully on the ridge board, and it indicates a precise cut that allows for a proper stable joint at the ridge. And like with anything else, if you see more than one bad cut being done, then you should kind of just keep your eyes peeled for other areas that would be common for errors like that to occur. Inspecting the cuts of rafters where they rest on the ridge board and top plates of exterior walls is important for several reasons, all of which contribute to the overall safety, integrity, and longevity of a home. All right, let's get into trusses. Um, Roof trusses are engineered roof framing systems in which the main components are designed by structural engineers and then assembled in a manufacturing facility before being delivered to the job site by a truck. So, how they're built, they're manufactured in a wide variety of configurations, have been around since the early 1950s. The main thing that you need to know is if you're in the attic and you see gusset plates or all these metal attachments, the thing to know about a truss is basically the use of angles distributes the load path through framing members that would otherwise typically be inadequate as a framing member. So if you have a roof that requires a 2x6 or a 2x8 rafter or even a 2x10 rafter, you might be able to accomplish the same load path you may be able to translate that load using smaller framing members using geometry. That's basically it. And if you're wondering which one you're looking at, stick your head up in the attic when you get up in there or go up in the attic. If you see a lot of gusset plates, you're probably working with trusses. And there's a bunch of different types of trusses. Time fails us to go through them all. Most roof trusses are designed to bear on the exterior walls only. And so they're in modern construction, open floor plans are usually achieved using truss construction. It doesn't make for a great attic space to walk around in for storage and things like that, but that's a sacrifice of having an open floor plan. As you can see in the illustration, the bottom cords of trusses should be fastened to the tops of interior non-bearing walls with slotted clips that allow for some vertical movement of the trusses. Truss movement can also result when truss loads exceed the structural design loads of the trusses, as might happen with the accumulation of lots of wet, heavy snow in an area. They're usually braced with a system of 2x4s and 1x6s when they're installed. The locations of bracing can be different for different truss designs. So, again, the primary thing you need to know about trusses is that they achieve really great load distribution with smaller framing members. And if you see a problem with it, they were designed by an engineer and manufactured off-site. So if you think you see a problem with one, contractors cannot go in there and jimmy with roof trusses and start fixing them unless it's signed off by an engineer. So even if you see an edit made to one, I might call it out, but instead of calling it out as a defect, I might call it out and say, ensure that whoever was responsible for this repair got proper documentation that a structural engineer signed off on the edit made to this truss and go from there. A case study, the garage of the house. This is a garage. The neighbor told the home inspector that the roof of the garage next door has collapsed during a big snowstorm. During the home inspection, it's easy to see that the trusses have been altered. Like we were talking about, plywood gussets, the wooden triangles were added at connections that would have typically had a metal truss plate installed. So the picture above is a metal truss plate. The picture above is a truss plate. Truss plates are metal connector plates. They're also referred to as gang nail plates, gusset plates, truss connector plates, metal plate connectors. They're thin galvanized steel plates with teeth that are pressed into the wood members on both sides to join truss components together. The teeth are punched through the plate and embedded into the wood under high pressure during the manufacturing process. If alterations involving plywood gussets have been approved by a structural engineer, the gussets usually have backing for perimeter nails installed. They're glued with a special construction adhesive and are heavily nailed with nails every 2 or 3 inches or so. You should also see a lot of nails and glue squeezing out of the joints. As you can see in the image, that wasn't the case there. So again, it should kind of jump out at you if you see gusset plates and you're dealing with trusses. If you see a lot of these types of things, which can be common, again, it could have been approved by a structural engineer. Maybe it wasn't. So you don't know which. There's some rules of thumb. If there's a bunch of glue leaking out everywhere, you know that they used a ton of glue. And if there's a ton of nails, that doesn't necessarily mean an engineer signed off on it. The lack of that might indicate that an engineer did not sign off on it. But either way, you're not calling it out as, I know for a fact this is a defect. You're calling it out as, hey, many times when these changes are made, they're not signed off by an engineer. Check with the previous owner or the current owner to see if this was a repair that they had done and whether or not that repair was signed off by a structural engineer. Roof panel sheathing. Sheathing and lumber are Terms used in the International Residential Code, they refer to panels manufactured with fully waterproof adhesive and include plywood, oriented strand board, and composite panels made up of a combination of wood veneers and reconstructed wood layers. Plywood panels are manufactured by gluing together three or more cross-laminated wood layers. OSB or oriented strand board panels are made from multiple layers of wood flakes oriented 90 degrees from each other. And you do need to install them in a particular orientation when you're putting them down as roof sheathing or sheathing below the siding. The minimum thickness of lumber roof sheathing should conform to the tables that we're showing here. And again, we're not going to spend a tremendous amount of time on this just because time sort of fails us. We're having to make up some ground here. So got 30 minutes. So we're going to go for it. A cornice is a decorative and protective assembly where the roof overhang meets the exterior wall, typically consisting of the fascia, soffit, and any trim moldings that create a finished transition between the roof and the building siding. That architectural feature not only provides visual appeal, but protects the roof-to-wall connection from weather while allowing for attic ventilation through soffit vents. They could be quarter-inch round molding, or they could be a larger profile, even including a dental molding or something like that. So you can see a cornice dental, cornice dental. You've got the cornice, the frieze, and the architrave. You can have all kinds of issues with those types of things, many of which just have to do with the wood itself kind of rotting out, because these decorative features are a lot of times on older homes and they can start to rot out and have inspection damage insect damage and things like that. In the inspection image, the vinyl siding is in contact with the roof shingle surface. There should be some clearance and separation between the roof and the siding. And that's true. And you're going to see there's different manufacturers with different preferences on that. And you can look those up and kind of use them in your report as a backup. Roof framing fundamentals. I would encourage you just to kind of like take a screenshot of that. This is a great or if you're an InterNACHI member, all these diagrams are available in the library, and you should definitely use these in your report for educational purposes. So if you're going to call out an issue with something, again, I use my report as an educational document. So if I want to reference something, I try to make sure that I'm not just using job site jargon that the normal homeowner or agent is not going to understand. So you can see in the chat, AJ put the nachi.org gallery on there. And again, I have plenty of diagrams from InterNACHI as an InterNACHI CPI in my reports, and they're just super, super helpful. Slope requirements and their relationship. Again, you have another thing that I would just take a screenshot of rather than go through every single one. There are certain things that just require certain roof slopes, and then certain things don't necessarily. Modified bitumen is not the same as asphalt shingles. The Clara concrete tile roof. Again, you're going to generally have two big categories. One is low slope roofing materials. One is steep slope roofing materials. Steep slope roofing materials, if you can imagine them, they're usually lapped materials where if water was to stay there and get under the material, it can get to the shank of a nail and leak into the home. Whereas a low slope roofing material is an impermeable membrane. You can see the fastening connections here of a rafter, a joist, and what's called a toenail, which is just a quick nail that you put in to fasten that to the wall plate. You'll notice a lot of different methods holding those components together. You'll have nails, you'll have screws, you'll have hurricane ties, metal connectors. There are all kinds of specific requirements for fastener size, spacing. They're detailed in the International Residential Code, and they're very specific. So if you see something in there, if you happen to be a contractor, don't think that you can just use whatever you think makes sense. These things are rated typically by engineers for there's been calculations involved as to why each particular connector is being used. So now you got collar ties versus rafter ties. I mistakenly used I used that term interchangeably a minute ago. That's not correct. A rafter tie, allowable rafter spans. Sorry. Collar ties and rafter ties are both horizontal roof framing members, each with different purposes and requirements. Home inspectors should be familiar with these structural members and the differences between them. They're not the same. In physics, Tension is the pulling force exerted by a solid object on another object. Tension members are solid objects that are subjected to axial tensile forces or tension. Collar ties and rafter ties are examples of tension members. So a tension tie is a structural member that's subject to net tension. So collar tie is a colloquial phrase that is used among contractors, builders, and inspectors, not usually used in construction or engineering documentation. The correct phrase is actually collar beam. For our purposes, we use collar tie. It's a tension tie in the upper third of an opposing gable rafter that is intended to resist separation of the rafter from the ridge beam during periods of unbalanced loads. They may or may not be required depending on the jurisdiction. InterNACHI inspectors should not call out a lack of collar ties as a defect unless they know that collar ties are required at the time the home was built in the jurisdiction where the home is located. So if you're catching the drift, maybe don't be so quick to call that out as a defect because you're going to have to know when the home was built. You're going to have to know the code when the home was built. And you're going to have to know the code in the jurisdiction of the home that's built. So even if it's appropriate, according to the IRC, it might not be appropriate in the jurisdiction where the home is located. A rafter tie is a tension tie in the lower third part of the opposing gable rafter that's intended to resist the outward thrust of the rafter under a load. In many situations, you'll find that ceiling joists installed parallel to the rafters are intended to function as rafter ties, which you're starting to see where, these are adequate framing members, but in modern truss framing, a lot of times that it functions the same way with those joists being used as the rafter tie. They resist the outward thrust that rafters exert on the exterior walls. They help keep walls from spreading due to the weight of the roof. And when the walls spread, the ridge board might sag. A sagging ridge is one indication that the roof structure may lack adequate rafter ties. So you can see the difference. Upper third, lower third. Compression at tension. Tension forces, right? Rafter and collar ties are subject to enormous tension forces. Those forces make securing the ties to the rafter boards a critical issue. As far as compression forces, as the load is applied downward, compression is increased at the posts. The rafter boards and the ridge board are normally under compression while holding up or resisting a load. The exterior load-bearing walls are holding up a load and are therefore under compression. So compression is direct downward force. Tension is, it's trying to pull apart. Outward thrust. The load on a structure can be calculated from combining the dead load or the weight of the structure itself, the live load that varies for different structures, the snow load, and the wind load. In a simple gable roof, the rafter boards carry the live and dead loads that push both downward and outward against the top of load-bearing walls. So again, you can kind of see the diagrams here. Great for your report. If you're seeing a defect, these would be good things to include in there. Although the diagram on the left does reference the IRC, which I would just be careful whether or not you're doing that. Bottom chord of a truss. In a conventional roof truss, the bottom chord acts as a tension tie between the exterior walls, like we started to mention a minute ago. Alterations to installed trusses are not permitted. Cutting any truss, particularly at the bottom chord, destroys the structural integrity of the truss. If the inspector finds that the chord of a truss has been cut, they should recommend immediately that a structural engineer be consulted. And again, in so many instances, you don't want to cry wolf and call a structural engineer. They pay $2,000 only to find out there's no issue, or $5,000 or whatever this guy's going to charge. But in the event of any kind of a modification being made to a truss without documentation, especially if you just see that it looks like maybe another contractor cut it to fit his plumbing pipe rather than use extra fittings or whatever the case might be. If there's a modification made to a roof truss, I would certainly recommend a structural engineer evaluate, especially like shown, they were looking to put probably the attic stairway in. And so they cut the bottom chord of the truss. So that can potentially be a huge problem. A bending moment occurs when a force changes from a straight form into a curved or angular one. The illustration shows a collar tie with rafters on top of conventionally framed walls. As the load is applied downward, the rafters go into a bending moment below the collar ties. That bending moment exerts outward thrust on the walls, forcing them out of plumb. So again, if you're suspecting this, you can take a picture with a level and recommend that a structural engineer evaluate further to determine whether or not there's an actual issue. 10 steps to inspecting a roof. We'll skip through this. Roof surfaces are measured in squares, so 1 square is 100 square feet. So if you have a roof that's 3,800 square feet, it's 38 squares. The most common type of shingle is called a laminated strip shingle and is generally packaged 3 bundles per square. So the inspector in the image above is inspecting a roof and identifying hail damage within a square section of the roof covering. And again, if you're going to evaluate for hail damage, Hague Engineering back in the 1960s developed a method known as the test square method. They originally developed it for cedar shake roofs, but it has been appropriated for asphalt composition roofs. It's a 10-foot by 10-foot test area that you evaluate to determine how many damaged shingles are inside that area. You extrapolate it across the rest of the directional facing slope. So however many directional facing slopes are on a roof, you would do 1 per directional facing slope. And if it's a massive, massive roof, maybe you do more than 1 to evaluate for hail damage. And really, it's not so much an inspection device as it is a quantifying device. So in other words, I'm going to look at an entire roof covering and the associated components, soft metal vents, ridge vents, all these other things. I'm going to have a whole story that I incorporate into determining whether or not I think a roof is hail damaged, rather than doing a test square and inspecting inside that test square. There's all kinds of outside components that can have bearing on whether or not a test square looks to be affected where the rest of the roof does not. So I would recommend inspecting the entire roof. And then if you're saying, I think there is hail damage here, I'm just wondering how to communicate how much hail damage there is, that's when you would employ a 10-foot by 10-foot test square, which really just communicates to whoever's listening, I think there's hail damage, but here's how much I think there is. So again, it's much less an inspection device and is much more a quantification device if you already think there's hail damage. If you don't think that there's hail damage to a roof, there's absolutely no reason to do a hail test square unless you're inspecting for the purpose of consulting for insurance companies, which I have thousands of times. So I've done thousands and thousands of test squares. Asphalt shingle compositions, those are by far the most common roof covering material. It takes up about 80% of the market share in terms of roof covering materials. They typically last anywhere from 15 to 40 years. Again, that's a huge span, but there's a hugely varied amount of different materials that could last one or the other. So, you have 3-tab, you have laminate, you have all kinds of different ones. In the embedded mat that they're showing here, you've got mineral granules on the surface, waterproof and weather-resistant asphalt, a fiberglass mat, and then another weather-resistant asphalt sort of sandwiching together. So the fiberglass mat gets impregnated and coated with asphalt and some other modifying materials, and then coated with mineral granules. So the granules really protect the asphalt from UV rays, and they increase the impact rating. Really, the fiberglass mat isn't always necessarily the only mat used. You can have an organic shingle where it's more of a felt paper mat, but you'll see those from a mile away because usually they're waterlogged and they're starting to break up. So again, huge market share, asphalt composition shingles, mineral granules, asphalt, matting, asphalt. That's usually the basic components of an asphalt composition shingle. The installation varies with type. As you can see, a laminated shingle typically has what's called a nailing line because it's 2 laminated portions of shingle. One of them is 12 inches tall, whereas that lower laminate portion is not 12 inches tall. It's usually like 5 5/8 inches tall. So there's what's called a nailing strip where the lower laminate and the upper laminate are laminated together. Where they overlap is usually only an inch and 5/8. It really depends on the material. And the nails need to be installed in that area, not only just to hold the lower laminate on, but because that's a point that's going to hold more of the shingle. So if they're high nailed, a lot of times you'll have that lower laminate sliding out. And even if they're high nailed, it causes all kinds of issues. Overdriven fasteners with gun pressure set to drive through 2 layers of asphalt shingle. It only drives through 1, blows through the shingle. The nails are not actually, the holding power of those fasteners is drastically reduced. So you've got all kinds of different asphalt shingle installations. It's really manufacturer specified. One thing that you may know or you may not know is really you would start a course with a full shingle on a corner of a roof, a full shingle, three-quarters of a shingle, half a shingle, and then a quarter of a shingle, and then you would run full courses off of that. That's called the stair step method. Another method of installation, which is sometimes appropriate for three-tab shingles, is called the racking method installation. I'm not going to get too far into it, but I would encourage you guys to look for it because it has its own issues. And again, I've taught many, many classes on these things. So if you need any kind of tips and tricks on recognizing these things, just reach out to me directly and I can definitely help you guys out. Why shingles deteriorate? They're designed to withstand decades of exposure to the elements. Their actual service life really depends on a complex interaction of environmental stressors, installation quality, and maintenance practices. So again, how the roof is installed is hugely important. How the roof is maintenance is hugely important. And then the geographic region, which leads to different climates, leads to different interactions with environmental factors. All these things kind of combine to affect the life expectancy of a material. So again, if you sell to, I forget whose point it was earlier, 15 to 20 years on a 35-year shingle in the state of Florida. If you're in the state of Florida, I wouldn't even use that. I would probably just use a clay tile like most other people down there, because hurricanes are so prevalent with really high winds. And, there's all these different things that can contribute to the failure of a material. But the main thing to know is that these are not forever materials. It's a weathering substance, just like a car tire. It has an expected service life, but that is in no way necessarily a warranty. It's considered a warranty, but that's if all things remain equal and nothing outside affects that material, which is almost never the case. It's almost always going to have foot traffic for maintenance. So if you're doing good maintenance, you're actually having people walk on the roof, which could potentially void the warranty. It's a very dynamic material and it breaks down differently for different reasons. So if you're seeing certain physical characteristics, I've spent years mastering each one and what causes it. So if you see something funky on a roof, if you see a vertical split in a shingle, or if you see something that looks like a bunch of ball peen hammer marks in a 100 square foot area, just take some pictures and let me know, and I'll give you a 5-second response on what it is, and then we can have a 2-hour conversation on what caused it. Asphalt shingle defects. Again, there's thermal cracking, there's granulose, there's blistering, there's curling, manufacturer defects, and then there's also hail damage, and there's also wind damage, and there's also all kinds of different things that can happen to asphalt composition shingles. It is a weathering substance, and as things start to get bad, they start to get worse. So an asphalt shingle, 5 years of age looks very different from 5 to 10 years old versus 15 to 20 years old. Things start to snowball pretty quickly. Once a roof starts to show signs of age, those granules start to shed and the UV light starts to get where it's not supposed to go, which is to the underlying bitumen. But again, it doesn't mean it's not supposed to go there. It's just designed to be withstood for a certain amount of years. And sometimes it can fail prematurely. Sometimes you can have a 20-year 3-tab shingle that lasts 50 years and nobody seems to know why. There is no perfect asphalt manufacturing process. There's a lot of times impurities in the asphalt, volatile gases that get trapped. There's all kinds of things that happen. So again, it's a very broad topic and a very dynamic material. So if you're seeing a material failure, best to educate yourself through different classes that are available online, partnering with certain experts, not unlike myself, where you can just, shoot a question. Or again, the InterNACHI forums are always useful. You've got seasons, years and years and years of inspection experience with all these different guys. So get in those forums, shoot a picture in there. And again, you might get a few comments about how silly you are for not knowing what that is. But for every one comment like that, you'll have 10 actually helpful professional inspectors who are out to help other guys and want to further their careers. Asphalt shingles, these are inspection pictures. Again, I could go through and tell you what all these things are. Lower left being 2 layers. We can talk about that another time on how to recognize that. But these are all defects. Probably the upper right photo is similar to what the lower middle photo looked like before somebody got to it and thought, I know what I'll do. I'll slap a bunch of heat building asphalt on top of the already failing material. That doesn't help. Slate tile roofing, awesome material. I love it. The image on the left is not a slate tile, just for reference. I didn't make this slide, so that's an S-type clay tile roof. It looks like it's always possible that it's concrete, but it looks very much like a clay tile roof to me. The other images are slate tiles. You have minimum headlamps requirements. You have to have at least a 412 slope. Well, I guess technically, like any other material, it's possible in certain jurisdictions to have it between a 212 and a 4 if underlayment considerations have been made. But typically, you're not going to use a slate roof on a very shallow slope because you want people to see a slate roof. If you pay the money for a slate roof, make sure it's on a nice slope where everybody can see it while they're driving by. Clay and concrete tiles, you got a few different types. That's Spanish, the curved, the flat shingle style, the interlocking. Again, beautiful material. I love it. You can have glazed like the upper right where they can color it with different things and it looks very glossy as a finish. And then there's sort of that terracotta look that's really popular, like I said, in Florida and some other jurisdictions like that. Again, they're very similar from an inspection perspective as far as clay tile and concrete. You may not know the difference, but there are ways to figure it out. Concrete's a lot better to walk on than Spanish clay tile. So either know what you're doing or disclaim it and don't walk around up there just saying, hey, this could cause a lot of damage if I walk around up here, so I'm not going to do it. Asbestos cement tile. If you know what you're looking at, you always can find it. Again, if you know anything about asbestos, not necessarily dangerous and it's just laying flat state. But if you go to make a repair on that, you turn it into its friable state. And I actually did inspect and write an estimate for an asbestos tile, and it was a 60 square roof, and just the mitigation was $90,000. So it's definitely something. If you can identify what that is, you can tell someone, hey, here it is. This is what it seems like it is. I can't confirm that it's asbestos without having it tested in a lab, but I would recommend having a piece, if available, tested in a lab, and then not ever touching it unless you have to. Wood shingles and shakes. A lot of people use those terms interchangeably. I'll tell you quickly what the differences are. Wood shingles and shakes. Shingles are machined and cut on both sides, and they're very, very even looking. And they're usually a little bit thinner. The shakes are kind of that more storybook looking, thick, variable exposure, variable thickness, and they just kind of have this old world look to them, whereas the shingles are designed to look a bit more uniform while still achieving like having a wood material. The age and condition of these materials, you can't really tell how long it's supposed to last because if it's very thick, it's supposed to last a long time, but that material can efface and look a little bit thinner when it's very much older than when it once started. So it could be a very old, really thick material, or it could be a very new, very thin material. Nowadays, like shakes were traditionally hand split. They're not so much hand split anymore unless you're somewhere very rural Ireland or something. But they're usually still machined, but they typically will just machine cut them on one side and leave that uneven side on the other. And what you'll need, if you understand roofing with underlayment, shingles can be installed over underlayment, whereas shakes need what's called interlayment. Because of their irregular sides, you need to have interlayment in between every course of shakes to stop water from penetrating where those uneven sides don't meet up beautifully. I would probably disclaim it unless you're an expert and you know exactly what you're looking at, because it needs to be of a certain thickness and a certain condition to be able to walk on it. When you do walk on it, you only want to walk on the headlaps, and you really don't want them to be wet. If they're algae buildup or mossy, they're going to be a slip and slide. So again, like this is a really high safety factor. Unless you would call yourself an expert in that field, I would disclaim it. Maybe move your ladder around a few different times or use a drone to inspect. Flat roofs with rolled roofing, you can see that these rolls kind of overlap one another. You put a roll down, you put some hot mop tar, and then you put another lap, and then you kind of saturate that and go over and over and over again. That's with a built-up roof. You can also have just a rolled roof that's basically just like a big piece of shingle, it looks like, and you can torch those down. You can lap them and seal them. They're installed different ways. But again, you're going to notice like that lower right photo, you'll notice that it looks like it's been rolled. It almost looks like it's a rolled on like an underlayment or something like that, but it's mineral surfaced, so you know that it's meant to be out in the UV rays, withstanding that. Built-up roofing. Sorry, I just mentioned this prematurely, but built-up roofing is really where you have some kind of a mechanically fastened insulation board through a roof deck. You'll have a cover board. You have layers of asphalt. You have plies, and you'll have what's called a flood coat on top, and then maybe some slag or some. A lot of people call them tar and gravel roofs. That's what I would call it, as a tar and gravel roof. But you can have a built-up roofing without that gravel. Doesn't necessarily have to have it. There's all different types. So again, if you don't know what you're looking at, but you know it's a flat material, the term single ply membrane would apply to most other materials other than a built up roof. A built up roof is a multi-ply membrane roofing system, whereas TPO, EPDM, PVC, if you're not sure exactly what you're looking at, try to tell the difference at least between a multi-ply system and a single ply system. And if you're not 100% sure what it is, call it a single ply membrane, unless you know that it's not. Membrane roofs, flat. Again, standing water is not designed to be on these. So if that's an issue, then I would call that out. You know, I would call it ponding or something like that. There's also things called like bridging towards the end when you have a parapet wall and that material is supposed to run flat to the corner and create a 90-degree angle going up that wall. If it's going in not meeting a 90-degree angle, it could be like an EPDM material where it's shrinking towards the middle with age, and that would be a condition known as bridging. EPDM, rubber roof, is what a lot of people call it. We'll just kind of touch these things as we go, and I'm sorry that we're running so close to time. I'll try to make up some ground and not cover these at their full depth. But again, it's really just a matter of doing your own research and understanding the difference between these materials, being able to speak to what the roofing material is, and then when there's obvious signs of degradation or issues, like that lower right roof looks pretty good to me. So, you know, if you're not seeing any real issues, don't call any issues out. Inspecting EPDM, they have weak points there, and then people think that a flat roofing material or a low slope roofing material is meant to last vastly longer than its sloped counterpoint, and that's not necessarily true. EPDM roofs are usually 20 to 25-year roofs, just like a 3-tab shingle. So, you know, look for irregularities, look for holes, obviously, look for ponding water. Look anytime there's on any roof whatsoever, any transition, roof to wall, roof to a change in slope, roof to a slope transition where it's just a change in the slope degree. Again, any of these changes are really, you know, you're rarely going to have just some glaring problem out in the wide open middle of a roof slope. It's going to be at a transition area. It's going to be where there's a drain or some other kind of roof appurtenance installed.
My energy.
Sorry. All right. Metal roofing. You can have metal roof shingles. You can have metal roof panels. You can have shingles that are designed to represent wooden clay tiles that are mineral surfaced. The lower right photo kind of shows a mineral surfaced metal roofing. Upper right is copper with soldered seams. Again, metal roofing. If you're not sure what it is, try to hold a magnet to it. If a magnet sticks, it's some kind of a steel. If it doesn't stick, it's either copper or aluminum, and hopefully you can be able to tell the difference. Sometimes copper is patinaed, and sometimes aluminum is painted to look like patinaed copper. So, roofing oddities, there's all sorts. That's a live roof right there in the middle. Drip edges, always important to look for it. A lot of times it's code, but very often it's not code. So it's not something you necessarily need to call out. If there is a lack of drip edge, you could just in your report state simply, I did not see any drip edge, and here are the potential fallout of not having drip edge on your roof. Ridge and hip flashing, again, much more important on any type of a tile roof. It's not called flashing if it's on an asphalt roof. Valley flashings, a lot of times with a shingled roof, you'll have an open valley, or in this wood shake roof, you see, or a wood shingle roof, you can see an open valley. You're not usually going to see a valley flashing on an asphalt composition shingle, you'll usually see either a woven valley or a cut valley. You can see open valleys, but it's probably going to be higher end if it's asphalt composition shingles. Roof to wall flashings, hugely important area for your inspection. Anytime, like I said, anytime there's any transition at all, you want to take a look at it. And if it's transitioning to brick, like with the chimney flashing, you want to take a good look at the step flashing and the counter flashing. The stair step flashing that you can see on a masonry chimney or on a brick wall is not the step flashing just because it's shaped like steps. It's usually counter flashing covering the step flashing. The step flashing goes under the shingles. Vents and other penetrations. These are areas where there's changes in the roof surface, so you're going to want to check these areas out every single time. Take a picture of every penetration that you can see. Soffit and fascia. Hopefully you can identify those by now, but go in the gallery and check it out if you can't. Airflow and ventilation is important at the soffit. Passive ventilation system, that's most common with asphalt composition shingles. You're going to have passive ventilation. And then you're going to have gable vents a lot of times, and sometimes those will be powered fans with louvers, sometimes not. Masonry chimneys. Again, check the flashing, check the caps. Hopefully you guys tuned in last week and we learned how to identify some issues with that. I know it's 9 o'clock. I got 5 more slides. I'll just flip through them real quick. These are manufactured chimneys, a little bit different than the masonry chimney. You'll see it's really just a metal flue chase, and then to cover up having an unsightly piece of metal coming through the roof, they'll put a box around it called a chase, and they'll have some siding on it and things like that. Again, just as important to check those for damage. We can definitely talk at length about inspecting roofs with drones. The only thing I would say, just like with any other piece of tech, like an infrared camera, drone, it's all the same. Make sure you're educated first and you use these technologies to supplement your existing knowledge and to get you information that you otherwise wouldn't have gotten. Don't let these technologies substitute actual experience and expertise. And then the last side was just some things to look for, which we've already kind of talked about. Check roof to wall flashing areas, check for prior repairs. And if you see a prior repair, maybe check inside to see if, the pre-existing damage has been corrected. Maybe there's some rotten plywood under there that they really do need to correct and they just covered it with shingles again. Not so good. And then every roof appurtenance, any flashing that's on the roof, always take a look at it, see if it's been installed correctly. But again, as always, you're going to need to know what the correct installation method is to know if it wasn't done correctly. So that's all for us. Thank you guys for coming to class. This is my contact info. I know we're losing some people, but if you're interested in contacting me, I don't charge. Just text me. We're all inspectors here. Just hit me up, email me some photos. You can use company cam, do whatever you want. Just get me the information and I'll get you the best answer I can. So good job, you guys. Thanks for sticking around. Love you all.